The Center for Clean Energy is one of the first interdisciplinary centers that Plaksha is setting up. And the reason for this is that the world of energy is undergoing a dramatic transformation.
When we imagined about Plaksha a few years ago, it was all about solving some of the challenges. The curriculum design is really based around that as well. As you look at our current one-year program that is ongoing and a four-year undergrad program that starts in August of 2021, it's going to be very interdisciplinary. While we will teach kids about technical education, but it's also non-technical and leadership. And this all will encompass us solving some of the grand challenges that face our country and the world.
The way we produce energy, the way we consume energy, and the way we manage energy, it's all changing. It's all getting a lot more decentralized and digitalized due to new technologies coming up and the increase in the use of renewables in this sector.
We plan to pursue and lead energy transformation with a very holistic approach at the Center for Clean Energy. How should we now leverage new tools like AI, ML, and data science to get efficiency, scale? How do we use new ways to get algorithms to manage these products and processes? This is something that the Center for Clean Energy wants to integrate with design thinking, behavioral science, and systems thinking.
Digital transformation in energy is one of our key focus areas. As the number of consumers and producers of energy grows significantly, we need enhanced and robust monitoring and control processes. Advances in sensor technology and deep tech like AI and ML have been vital for these processes.
There are many problems like air pollution, clean water, waste management that need remedies. If we are able to bring solutions to any of these problems, we would feel that we have made some impact.
The Center for Clean Energy will work to create world-class professionals that meet today's industry's requirements. It will conduct cutting-edge research and will accelerate the deployment of new technologies in this area.
Over the next 10 to 15 years, we would like the center to emerge as a torchbearer of clean energy transition, democratizing the access of clean energy to every citizen in India and the world.
A very good afternoon to everyone. I'm Piyush Sharma, currently a Tech Leaders Fellow at Plaksha and your host for the day. Welcome to Digital Transformation in Energy, the inaugural conference of Plaksha Center for Clean Energy. Plaksha Center for Clean Energy is an upcoming initiative to work at the confluence of interdisciplinary education, research and innovation, entrepreneurship, and public-private partnership to champion efforts towards energy transition and global decarbonization. The three exciting sessions in this conference are built around disseminating inspiring stories about clean energy transition and the deliberating promises digital technology holds in global decarbonization. I hope that this conference will be a memorable experience for all of you. We will begin the opening session for today with a fireside chat with Shalini Serene and Manas Floria on solving energy challenges of the 21st century, moderated by Sudhir Pal Singh. Sudhir is an editor with ET Energy World, a media platform by the Economic Times focusing on energy issues. Manas Floria is the co-founder of Nagaro and founder and trustee at Plaksha. Shalini Serene is the co-founder and executive director at Electromobilitet and the trustee and chair of the Plaksha Center for Clean Energy. Sudhir, may I please invite you to moderate this session?
Thank you, Piyush. Ladies and gentlemen, a very good afternoon to all of you and a very warm welcome on this platform today. I'm Sudhir and this is a fireside chat on solving the energy challenges of the 21st century. And of course, we have an eminent set of panelists, which includes Shalini Serene and Manas Floria. They have been already introduced by Piyush. And both of them are leaders in the energy transition in the larger industrial transformation space. Let me begin this discussion by asking Manas to give us some context. Putting the entire discussion in context by telling us what is the idea of Plaksha and how does that align with the larger energy transition trend that is being witnessed not just in India but globally at the moment. Yeah.
Sudhir, thanks for having me. It's sort of ironic that we are seeing a fireside chat and talking about energy, or maybe it's very apt. So let me talk a few words about Plaksha. So Plaksha is basically a philanthropic effort to set up a world-class university, totally world-class university. And the amazing thing that I like about it is that it has a lot of founders from all over the industry. So you have, for example, the classic entrepreneurs like Hitesh Oberoi of Naukri, Voyage, or Pankaj Chadda of Zomato, and the classic entrepreneurs. You have people from the large tech companies like Gagan Hastir of Netflix and folks like that. You have people from venture capital. You have like Naveen Chadda of Mayfield and people from Sequoia. More classic capital, from Warburg Pincus, etc. Arcesium. You have people like Pramod Bhasin, Vineet Nair, who need no introduction. You have consulting firms like people like Neeraj Agarwal from the Boston Consulting Group. So a lot of very incredible people, from education like from Vidya Mandir or Akash and so on. So I can go on and on. So literally dozens of people who have gotten together to invest not just their time, and not just their money, but also their peace of mind, if you will, to try to imagine how can higher education be changed in India. If you compare India with the US or compare India with China, even we are very far behind. And China, for example, is investing so much in R&D and starts by building up the universities. And India is really far from that. So just to summarize, I think the name of the foundation itself is called Reimagining Higher Education Foundation. And the idea of Plaksha is to do this not only for us ourselves, but for universities and higher education all over India. That's at least the idea.
Okay. Thank you for giving that context about Plaksha, Manas. So you're talking about reimagining higher education. Can you help us understand what do you basically mean when you say reimagining? In what ways we are tinkering with the basic concepts, and in what way we are able to see the kind of impact that it is having over the years, and particularly from industry connect point of view, what is it that you can tell us? The kind of industry connect that the initiative has been able to bring about. And if you could give some examples to help us understand what exactly are we trying to achieve here.
Yes, absolutely. So you can see that a lot of the founders are also engineers, a lot of them from the IITs. And Many of them have also studied overseas, and to some extent, the idea of reimagining is to bridge the gap between what we learned overseas versus what we learned in India. But it's also about the reimagining. For example, with COVID, the entire idea of university is also called into question. So there are many dimensions of reimagining, and I'll just try to talk about a few of them that are most important. So one is, about the idea of tinkering. So, in India, our engineering is mostly theoretical. So barring a few places in a few universities, it's very theoretical. So we don't build things with our hands. So I like to joke, a lot of us like to joke that an electrical engineer from India would not even be able to change the fuse in his or her home. And that's kind of the sort of the negative of India. In software, somehow it's virtual and we are able to do that. But when it comes to the real world, building real things, we're not very good at that. So that's one part. And very closely tied to this is that we are not solving for problems, right? So, we are not coming up with solutions because we're not out to build things. So, we see around us, if you look at the air, you look at the water, you look at the roads, all kinds of problems, but we are typically not solving for challenges. And the whole education in universities is not about solving for challenges, but rather solving textbook problems, and that you get better and better at doing that rather, right? And so the idea is also to sort of rethink, what is being taught and how it is being taught. So on the how, for example, the latest research shows that the 1 hour lecture, in a sort of monotony is a very bad way to learn. So a typical attention span is just 10 minutes, right? So how do you make the learning more interactive, more experiential, shorter bursts, flipped classrooms? But experiment with also the way of learning, right? And especially when in this COVID-induced age, right? So, but also, what are you being taught, right? So understanding, for example, in energy, right? So we can learn about the formula of energy, but how does it fit to the socio economic sort of context of India? So, for example, if you have poor people who are not able to, keep themselves warm in winter except for lighting, small bits of trash, or you have waste management issues that lead to trash being burned, for example, then we don't have necessarily a solution to this clean energy challenge, right? So things like that. So the idea of but the key idea, and all of this are various different dimensions, but it all comes together in this industry connect part. Because when you say that you're going to build a center or a university that is very closely tied to industry and can really co-create with the industry, that forces you to look at tinkering. It forces you to look at building, and forces you to look at scaling up the leadership of these individuals to actually be able to work with industry problems. So that's kind of what we are focused on at Plaksha, and also at the center. It sounds like a mouthful, but ultimately, a lot of these problems have been solved, or at least they have been analyzed. We try to bring it all together and build something that's state of the art, and not something that's reflective of what the latest thinking was 20, 40 years ago.
Yeah, okay. That's thank you for those initial comments, Manas, and that really helps us put things in perspective here. I'll turn to Shalini here. Shalini, what's your understanding? You've listened to Manas, right? And he has given us a fairly good idea of what we're trying to achieve here. What's your sense of the vision for the Center for Clean Energy, and what is the approach being taken? And if you could take the comments made by Manas a bit forward by telling us in what ways it's more linked to the larger energy transition scene that is, or the landscape that it's evolving around us in India and globally.
Yeah, thanks, Sudhir. And I think keeping the ethos of Plaksha in mind, the Center for Clean Energy Transition essentially is working on the development and welfare of society and the planet for developing relevant technical skills which are required in this transition, leveraging the digital transformation that is happening for academia, for lifelong learning, for application research, and of course, we want to, our ambition is to create at least half of the batch to become entrepreneurs. So enable setting up incubators and startups in the energy space. So Center for Clean Energy, also like Plaksha, keeping the ethos, wants to be able to collaborate very closely with the industry. And like in the US, you have the ICURC, the Industry University Collaboration for Research. We intend doing the same, and therefore have a lot of very senior advisors from the university, from the industry, from the development sector, which has played a very significant role in energy, of course, with the government as well, to be able to give us the right direction and impetus. So, industry collaborations, think tanks, NGOs, development sector, government, to be able to influence policy. And in a nutshell, if I was to summarize, we will be creating relevant workforce, which is through academia and lifelong learning. We want to be able to create application research, patents, IP, and lastly, of course, be able to create energy incubators, because we want to be able to create job creators and not just job seekers, and we need a lot of that, especially in energy. So while you see, Sudhir, that there has been a lot of transformation that has happened in the energy space, and I can summarize it in 5 Ds, the way it has happened: decarbonization, decentralization, digitization of energy, decoupling of energy from the demand and supply, and lastly, democratizing energy. Keeping all of that in mind, on the supply side and on the demand side both, there are a lot of changes that are happening, from fossil fuel to renewable. And in fact, India is one of the fourth highest installed capacities in the world, with already about 135 gigawatt, and having an ambition initially of 175 gigawatt by 2020, and now Prime Minister Modi has pushed it to 220 gigawatt by 2020, and by 2030 be 450 gigawatts. Solar, we are taking leaps and bounds, and ISA is a global example, where the first of its kind UN body headquartered in India and has given it a big push. And with Tesla coming to India, having an ambition of at least 30% of vehicles moving to EV. And lastly, of course, with net zero, I'm sure we all know that with these smart buildings and net zero buildings, we can optimize and become carbon neutral for our consumption. So yeah, so from supply side and demand side both, because we can continue to have as many sources of supply, whether renewable, nuclear, or whatever, but we'll be like catching our tail if we do not work on conservation and smart products from the demand side management. And lastly, of course, management of energy and distribution, and to ensure that the supply, the distribution and transmission is managed more efficiently and manages scale in India. So yeah, that's the.
Yeah, thanks, Shalini. I would say you haven't left any important topic which is not covered here. You've touched upon all the really important topics within the larger transition or transformation domain. So we have got that perspective from both of you, and I would say, taken together, that's a lot of noble ambition, right? What we're trying to achieve here, particularly because we very often see industry complaining of lack of skill sets, lack of technology, wherewithal that should exist in a sector which is so rapidly evolving. But let me ask you, Shalini, if you could brief us on what exactly is the larger roadmap, or the priorities that we are talking about in the over the next, let's say, 2 or 3 years time frame, that we want to focus on when it comes to achieving these goals?
Yeah. So, Sudhir, the way we envisage our roadmap and our priorities now are, we want to initially start with professional development programs, and our campus will be coming up in 2021 itself. So, by fall of this year, our campus will be ready in Mohali. We are already doing our pilots and engaging with a lot of companies for their in-house programs on professional development, which is lifelong learning for mid-level and senior level professionals to be able to upgrade their capabilities. We want to be able to very soon, and we already have electives for our masters, and then research programs which have already started for whether it's net zero buildings or carbon pricing. We've got some research projects going with a couple of private sector. And then we will, of course, be having a full-fledged one-year program in energy and research in the application area, whether it is mobility, buildings, agriculture, healthcare, cutting across all applications.
Okay, fine. Manas, what's your sense of the kind of role that that the Center for Clean Energy can play, in this larger perspective on industry connect, what we're talking about here, and that industry connect is required, is definitely required, and it's lacking, right? So it's one of those really important areas that have to be worked upon. What's your role? How do you visualize that role? And what are the specific areas that we want to take up?
You see, I think that in topics such as this, there is this concept of a tipping point, when enough forces sort of get aligned to create dramatic change. I think that the conditions for a tipping point in energy are ripe. The challenges are very significant and clearly visible. If you look out at the sky, you can see the big challenge with about clean energy, for example. But all the way through, through the entire spectrum of things that Shalini just mentioned. And I just feel that, we are industry, right? So we are all industry. Even our big, IT services industry that I represent, and along with me, there's, for example, CP Gurnani for Tech Mahindra and the Emphasis CEO and so on the, even we are really into energy in many ways. So we are, for example, not just, building campuses, etc., which is as you consumers, but we're also working with energy on energy-related products all the time. So the leading energy management software is being built right here in India. Whether you talk of, so a lot of these products are being built here. Unfortunately, I think we have, for example, consultants who are consulting with the government, on energy. We have, one of our founders is from IIT Bombay. She's working in Sitara there, which is on energy again with the states on how to solve some of the states' challenges in energy. So the idea here is to actually try to align our understanding, our strategies, and not just be consumers, right? Unfortunately, today in India, whether right from the most of the cars that we buy to the TVs that we buy to the mobile phones that we buy to the energy products that we buy, we are just customers and consumers of these products. We are not really building anything sophisticated here. Not even waiting on the fringe of the core products that are already being imported, or the designs are being imported. So I think in all of these areas, a little bit more of ambition. I know what Shalini is laying out is a bold, large plan, but all of us have built bold, large companies, right? And we have that. We have the confidence that we can start tackling this piece by piece and building it out. And again, we are industry, right? So we want to use all the little things and tools that Plaksha will give us, like capstone projects, like internships and all kinds of things, to sort of help drive this agenda forward in the topic of clean energy.
Okay, yeah, thank you, Manas, for that important comment. So because we're talking about tech here, and you're part of the industry, and Shalini has already talked about digital transformation as a topic, and the tech industry has a very important role to play there. And all of this is coming at a time when the entire sector, the energy sector, is going through a lot of transition. The thing that comes to mind is that one of the things that that's really important here is to understand that at some level, when we discuss tech-related aspects, there is a cost element involved there. And if you look at the energy sector, particularly the chain of the energy sector, which is at the consuming end, the discoms, not really in a healthy financial shape. So what are the ways in which we can maybe from a you can have some recommendations on policy front, for example. But do you think that could come as a constraint, or in what ways we can maybe as a country tackle that? What will be your recommendation as a tech industry leader to address that very crucial aspect?
You see, I think that the government plays an important role, right? I mean, as much as as capitalist as we want to be, at the end of the day, there is a role for the government to set out a vision for where we want to get to, and to take all the decisions en route to get us there, right? So I think we are seeing that happen in some topics, like, for example, electric vehicles, etc. But even there, we can always, we are a contentious and quarreling nation, argumentative nation, I would say, which is a good thing. But it takes us a long time to agree, for example, on standards, on processes, on how things will work. And so I think that, we work, for example, with some car manufacturers, and I'm even surprised that in the EV space, everybody's waiting and watching, what decisions will get taken, how will they get taken, right? And I think we need more of these forums, very, very visible forums, to drive that consensus, that to drive the policy, to potentially help mold that policy, to help mold the steps on the way to that vision that we are working towards. So, I think that if you look at all the large moves that the developed countries have taken, or even more recently China has taken, I think it's been driven by a strong vision of what they are trying to build, and then trying to align everyone to that. So in a way, I think centers such as this will help be that that alignment. And of course, we all have to work on this. There's a lot of work to be done, totally at every level. But we want to bring the horsepower to bear, right? So we want to contribute the horsepower of the center to driving this forward.
Okay. Thank you. Thanks, Manas. But so you have talked about having a vision, and that's very important, no doubt about it. And when it comes to vision, and like Shalini was also talking about it, on renewable energy, we have laid out a really, a vision for a long-term plan, and a strong vision there. On EVs also, right? We have really tough targets to meet. But let me ask you, as an industry leader, how do you look at this entire scenario panning out? As a country, are we taking the right steps to achieve this entire, larger transition, goals that we're talking about, whether it's RE, whether it's EVs, or whether it's related areas? We're talking about a lot of innovation and a lot of new tech that has to come into place. Are we taking the right steps? For example, one of the arguments that I very commonly come across is that people say that, in EVs, for example, there was and there is a large scope for a country like India to set up large manufacturing capacities. So that something of the kind that happened in solar doesn't happen in EV, right? In solar, for example, 80-90% of our equipment comes from China and Taiwan also. Now, so in a way, we miss the bus there. Are we going to miss the bus when it comes to local manufacturing in EV? And what are the steps that we can take to ensure that that doesn't happen, that we don't miss that bus? As an industry leader, how do you want to comment on that?
So I'm going to say something which may be a little bit controversial, but I'll just say it anyway because I believe it. I think that our country is still not very conducive to manufacturing, right? And it requires a very large scale to be a reasonable manufacturing company in India. There are so many procedural and challenges. I mean, just electricity, just start with electricity, right? And we don't even need to go further than electricity, right? So, which also, by the way, is energy. So we're right at the point where we started. So I think there are huge challenges. So if you look at, you look at entrepreneurship, if you look at the power of building great companies that can compete internationally, look at what has happened in software, right? There's huge sort of energy and power because software is easy to run. You don't need to have trucks on the roads your trucks can't be stopped by policemen and excise and all that. That's simplified now. You don't need that much energy. You can have your own small generators and manage, and cost of energy is not such a big thing. So I think there are problems with manufacturing, and I think what I would suggest is that we need a two-pronged sort of approach. On one hand, we need to fix the very, very basic issues, very, very basic issues. I think that I mean, starting with education and health and air quality. We should just start with a basic. Even in this place I live in the middle of Gurgaon, I can't get 24. I have a UPS that's meant to sort of just filter out all the issues. And downstairs you have a generator in the apartment complex. It's just not sustainable. And the amount of pollution and the amount of the battery pollution and all that this is causing is just a waste. So I think the standards of our very, very basic services have to be really high. And we talk Six Sigma in industry all the time. Where's Six Sigma in government services, for example? I mean, we have to really work towards that. So that's one level. At the same time, we can't wait for everything to be fixed before we, reach where we want to reach with our vision. And I think there we need to take bets that are doable, right? Things that are narrowly doable, and maybe not get caught up in our own, in our own speeches, but just focus on things that are really doable. Even if it is not, building the entire mobile phone, right? But even if it's just assembly, which we have started to do in larger and larger numbers, but just similarly in energy to look at what are the achievable bets and then to focus and really try to do them, right? And I think, yeah, it's not easy. It's not easy to turn a whole country around, but I think it will really help to fix the very, very basic things at a very steady level, and then also pick, some chosen areas where you want to be world class at a higher level.
Okay, yeah. Thank you, Manas, for those really important comments. It's not easy, that's the takeaway I have from there. It's not easy, but definitely, what I can tell you based on, whatever understanding I have is that there have been, and there are a lot, a lot of centers for hope which are coming up. So, for example, a lot of, initiative is being taken to set up battery manufacturing capacities in India at the moment. And that's the kind of thing that never happened earlier, right? Otherwise, storage would have been a different story today. So we are taking the important steps when it comes to the crucial aspects of this transition. But let me turn to Shalini here, and she's been listening to the entire conversation. And I want to understand, Shalini, if you can give us a closing comment, something similar to what Manas told us on, what's your sense of the transition? Are we taking the right steps? Where do we stand currently, and where are we headed? Yeah. And this is very important particularly from the point of view of the larger job creation aspect that we have to tackle. And Plaksha's initial comments, you also mentioned that that's one of the what we are trying to achieve here, right? So yeah, Shalini, please.
Sure. So Sudhir, I think I'll expand a little bit on the EV comments that Manas made, since I'm in the EV space now with my startup. And so while we are putting a lot of incentives while there is a lot of, chicken and egg, which is happening between the manufacturing of vehicles and the infrastructure. Because if there is no infrastructure, the vehicles are not going to be viable, and vice versa. So and both are looking at each other. So I want to invest in a vehicle and I want to go green, but if there is no adequate infrastructure for charging, I'm going to be disincentivized, and similarly. So the government is doing a lot in terms of giving incentives for the vehicles, but it has to also demonstrate the same on the infrastructure, which many of the state governments have started. There again, sometimes we end up making those mistakes that we've always made, that we need to get the cheapest possible technology with something like the Bharat chargers, and we all know the story of what happened. And now whether we are going to align with the US technology or European technology, the CHAdeMO, CCS, and AC type 2, or we need to get a universal kind of a charger, we are at that benefit and inflection point where we can choose the right technology, like we did in telecom, with GSM and CDMA. We were the latecomers, but we had the benefit of others' learnings, so that we don't make the same mistake and don't go for the cheapest option, because the BMWs and the Audis, they are not going to come up and they will not trust the cheapest charger with their most expensive cars. So I think that's something that we need to work very closely with the industry and the government to be able to influence policy. And that's why I said our course is interdisciplinary, where there is going to be cutting edge technology, but at the same time, there's a lot of focus on forecasting software, AI for smart grids to predict consumption. There is a lot of dependence and interplay between the hardware, the software, the application, the behavioral change, because we've seen each of these steps are equally important in adapting or adoption of that policy. Otherwise, the policy is as good as it is, like we saw with iridium. It was way ahead of its time, and that's why the adaptation was not so quick. So what I'm trying to say is, for example, now with the new ESL tenders for EV buses, unless I'm able to have my engineers as equipped on the software of forecasting the fleet management, what is the time taken, what is the forecasting, what is the turnaround time, how much load can the bus take, all of that simulations are equally important. And that's why our intent is to have an application oriented engineering. So it's not pure science, but it's engineering programs that are going to be encouraged and in collaboration with the industry. So yes, we want to collaborate and work very closely. And like I talked about, many companies in the energy space who are already collaborating with us, the multinationals like the Schneider Electric, Siemens, etc., the Indian giants like the Tatas, Mahindras, etc., the think tanks in the energy space, like the CEW, ESL, etc., and also, the development sector and World Bank, Rockefeller, all of them, to be able to get a very holistic curriculum to develop the right, relevant.
Okay. Yeah. Very important comments by Shalini there, and she has dropped so many topics. I'm tempted to discuss them threadbare, but time is short, ladies and gentlemen, and I think we'll have to close it. Let me say that we can close it with the key takeaway of what Manav said, that the task may not be easy, it may be difficult, right, of aligning ourselves with the larger energy transition goal. But like what Shalini said, we we are at a juncture where the decisions that we take now is a time when we take the decisions that will have a long-lasting impact on where we go, in what shape, and what is the shape that our transition takes. And a lot of learning is there from global learning is there, no doubt about it. So let me close the discussion there. And thank you for your time, Shalini, and thank you for our time, Manas. Please carry on. Thank you.
Thank you, Sudhir.
Over to you, Piyush.
Thank you so much, Sudhir, Shalini, and Manas, for sharing your thoughts on some of the key challenges in the energy sector and the unique approach Plaksha and the Center for Clean Energy will follow to make an impactful change in society. We now move on to the keynote address for the conference. We are fortunate to have with us Gauri Singh, Deputy Director General, International Renewable Energy Agency, to deliver this keynote. Gauri Singh has been instrumental in implementing flagship clean energy projects with her past roles within central and state governments in India, and she continues to do so as a global leader at IRENA. She will be talking about the role of digital technology in global energy transition and the opportunities it holds for India. Ma'am, we request you to deliver your keynote address to the audience.
Thank you. Thank you, Piyush. And thank you for inviting me to this webinar. And I have to say that I really enjoyed the fireside chat, just listening to what Manas and Shalini were saying about their vision of how Plaksha would come together and develop. I think it's really very exciting to hear that, and to see where their vision is going to take them. So let me start by first, giving a more of a global perspective, and then maybe coming to the Indian context and talking about the digital technologies and what the interface would be in the power sector. And as we know, last year has been a challenging year in more ways than one. But for the renewables, it's been fairly catalytical, because it's kind of changed the way and the speed at which things were moving. I think it's been a year where the world's kind of hit a pause button and is trying to reimagine what the future should look like. And there is obviously a momentum growing around it, with countries after countries coming in to give their and state their commitments for net zero moving ahead. So maybe Piyush, if you could just have the presentation, could you please show the slides?
Yes, ma'am, we will right away.
Could we come to the first slide? Yeah, so the nature of energy is definitely changing, and we are now talking in terms of where we want to head in 2050, and we all know that the emissions, the carbon emissions, energy is one of the main sources of creating these emissions. So what you see here are 3 bars. So if we look historically, and if I say, you had the Paris Accord in 2015, and since then we are looking at compound annual rate of growth of emissions of about 0.7% per year. Which, if they continue the way they are, we'll probably end up reaching something like 43 gigatons by 2050. In the middle, what you're seeing is the planned energy scenario. So planned meaning it's been at IRENA, we analyze what the countries are saying they would be committing to, what are their national plans looking like. And what you see here is that we'd probably be increasing our emissions slightly by 2030 to from 34 to 35 gigatons, and then slightly decreasing to 33 gigatons, which is, it's probably it'll take us to something like a temperature increase of 2.5. So obviously we don't want to head there. And if you see the energy demand, it would move in the planned energy scenario from around 600 exajoules to around 710. But you do see that the fossil fuel pretty much stays at the same level, which means that renewable energies would start becoming a bigger part of the energy profile. But if we are to actually reach a stable and a climate safe and a sustainable long-term energy and economic development plan and a future, then what we need to be looking at is the transforming energy scenario, which is in the third bar that you see, where you're actually looking at the fossil fuels declining substantially from the levels that they are today to 130 exajoules, where coal would probably be hit the hardest with the hardest decline, and also with oil showing a substantial decline. But that's probably what's needed to be able to reach or to be able to sustain the temperature rise to 1.5 degrees, which is what we all globally would want to do. Can we move to the next slide? So as I said, it's been a decade of really exciting growth for renewables, where renewables has been growing rapidly, and it's also grown in 2020, while many other sectors were obviously facing challenges. And you do have, in India, for example, we have a quarter of the capacity deployed is renewables, but it adds only about less than 10% to the generation. Can we move to the next, please? So this obviously has been one of the big drivers for renewables has been the declining cost, and they have declined really rapidly. In fact, in most countries, the cost of new thermal is more than the cost of renewables. And to put it in perspective, what it means is that if today we were to retire 500 gigawatts of the least competitive thermal capacity in the world, with solar and wind, and substituted with solar and wind, we would probably end up saving something like $12 billion a year in the cost of power. So that's the direction in which we are going, which is extremely exciting, because now it's really not a question of whether renewables makes economic sense. It does, obviously, and we've seen in auctions in India where the cost is now it's close to 2 rupees a unit, which is obviously really something quite unimaginable. I mean, I can tell you that 10 years back, when we were doing the first solar auctions, I mean, we were really excited when we saw that the prices came to something like 15, which were much below what was being predicted at around 19 rupees per unit. But now with auctions going the way they are, it's a completely different ball game. Can I have the next, please? Yeah, but it's as you can see again, maybe the way we will head is still not enough for us to be able to make the kind of shift and to make the energy transition that is required to keep the emissions in check, to keep the temperature in check. And what it means is that renewables will need to grow almost 6 times where they are today. And that's pretty much where we need to head. Can I have the next slide? So, the transforming energy scenario would mean creation of 22 million jobs, would mean full energy access, improved security, better air quality, and obviously a push in the GDP, apart from the emission reduction that it would lead to. So it's it's something that the hope that we have now with the EU going for very, very strong targets and moving towards carbon neutrality. Korea has come out very recently with their roadmap. So has Japan, which has said they're not going to be funding any more thermal projects. So these are all very, very good signs. Can I have the next, please? And before I get more into the digital technologies that I'll be talking about, I just want to stress on two of the technologies which among the many other technologies, I think these are two really which one is really betting on heavily, and it makes a lot of sense even for India. Are the utility scale batteries, where lithium ion is obviously now really is a front runner on this, because this is having batteries put on the congested grids can actually not only just provide backup of energy storage during any contingency events, but also they create the virtual transmission lines that could defer or even avoid the need for physical transmission lines to happen. And in fact, some of these very large pilots that are there, you can see that in Australia, the Tesla battery of 100 megawatts has, in fact, got the energy company in Australia to put many more, because it's the way it has actually served the purpose of deferring investment on increasing transmission lines. And Korea, for example, has also now been thinking of moving more to distributed utility scale lithium-ion battery systems. The other one that I'd also like to speak about is green hydrogen, which I think is really important, and it's an emerging area for India, especially because the new hydrogen mission has just been announced, and we all know in India we have these large public sector units that produce ammonia for fertilizer industry, and having a shift towards green hydrogen embedded in the ammonia molecules is something that could actually be a game changer in the way we look at energy, and it's obviously something that would help to decarbonize the more difficult areas like the long haul transport, the industries like steel and chemical. So these are the two technologies which I think we need to really build our capacities in India. And probably with the new hydrogen mission, I think it's clear that we're moving in the right direction. Yeah, so moving on to the digital technologies like artificial intelligence, Internet of Things, and blockchains. These are actually I would say changing the boundaries and dynamics of the power industry and helping optimize the renewable assets. So, one can look at digitalization as a key amplifier of the power sector transformation, as it will obviously help us manage large amounts of data and optimize in an increasingly complex system. I was on the board of directors of a holding company, and I can tell you that less than 10% of the data was actually being used and being analyzed to do better management. And I think these are technologies that can definitely help us move in that direction. And the two trends that are lending themselves to this whole importance of digitalization in the power sector are the decentralization and the greater thrust on electrification. So decentralization, as traditionally, that we had thermal plants, we had hydro plants, which were very large plants at specific locations, and that's how our energy systems were built. But now with the large number of small generators, also large generators in the terms of the solar parks and the wind parks that are coming up, and them getting, and even the rooftops, there are these very large number of generating points that are coming up in the power system. And the EVs, the electrification of transport and industry, will add to new loads. So in a way, what we're seeing is that both on the supply side and on the demand side, there is the complexity of the power system is getting much more. When you think EV, in India, you don't think Tesla. You're probably thinking the 1.5 lakh scooters that are sold annually, and the double-digit growth that's happening with them. And with the new policy coming for EVs, I think we'll definitely see this kind of a distributed demand that will add to the existing system. So, at IRENA, our focus on digital technologies is basically for looking at how they would help in the integration of variable technologies in the power system. And while none of these, none of them is a silver bullet, but rather each reinforces the other as a part of a toolbox of digital solutions, which are needed to optimize the operations of an increasingly complex power system based on renewable power. Can I? Yeah. No, can you just go to the slide earlier? No, earlier. Yeah. So if you look at the three largest power systems in the world, which is China, India, and United States, they are expected to double their variable renewable energy shares to more than 10% of annual generation by 2022. India, as I said, is already around around 9%, reaching 10%. So as the shares of variable power increase, the digital technologies will become extremely important for managing power systems. So traditionally in a conventional power system, you had the supply side providing flexibility by adjusting the generation to follow demand. Demand side didn't have too much flexibility, and it was largely unresponsive. But now with the innovations that are emerging, you will see both supply side and flexibility in all segments of the power system. And one would probably be looking at digital applications, creating new value streams for different actors in the power value chain, from generators to consumers. as I mentioned, you don't have. I mean, although AI has existed for a long time, but it's only now that it's been able to take advantage of the large data sets that are available for providing meaningful learning and results for energy market applications. And this combination, in fact, could help integrate the variable renewable energy into the power system by increasing the accuracy of renewable energy generation forecasting, by improving the operation of the system, and also better management of the distributed renewables assets. So, really exciting times ahead where blockchains, for example, it's been discussed in the power sector that the biggest disruption in the power sector could come from blockchain integration. The power sector is a highly centralized market structure with a strong regulatory environment. So this is really a sector that makes it very amenable for the application of blockchain technologies, as electrons can get traded instantly with minimum transaction fees in a decentralized network, and payments can be processed almost simultaneously. So you'd probably also see a whole area of automated smart contracts based on blockchain technology that allow for distributed energy resources to be bundled as by aggregators. And I just maybe want to say before I end that a lot of you who are urban consumers and want to go green with the kind of energy that you're using, I think with rooftops being one of the ways, but you probably would also see virtual rooftops getting defined, which would again be something that enables a urban consumer who doesn't have a rooftop but wants to go green with their energy consumption, being able to come into the energy market and trade in this space. And these are clearly technologies which, whether it's blockchain or Internet of Things, that would enable this kind of way forward. Can I just have the last slide? So I just want to end by giving you the current landscape in terms of digital applications. And you can see that except in the transmission, we're pretty much at early stage in generation and distribution and consumption. And that's why I think it's very exciting time ahead, because whether it is supply side flexibility solutions or grid flexibility solutions, demand side management, or system wide storage flexibility systems, all would need analytics based on big data, would need technologies powered by Internet of Things and blockchain. So let me just end it here by saying that I'm really happy to be here and to be able to speak to all of you. Thank you.
Thank you, ma'am. It has been incredible hearing your thoughts about synergies between digital and clean energy transition and the possibilities they hold for this planet. Thank you so much for this opportunity, and we look forward to your guidance and support in building this center in the future. As we move into the next session, it would be worth our while to hear some impactful stories of change. The energy sector in India is full of inspiring stories that have created sustainable change on ground. In our next session, we bring two such stories to our audiences, followed by a fireside chat moderated by Shalini Serene. We have with us Harish Hande, co-founder and chairman, Selco India, who is an inspiration for all of us. In his well-adorned career, he has touched many lives with his venture to generate livelihood opportunities through solar energy. Harish will be sharing with us glimpses of his journey during this talk. Over to you, Harish. May I please request Harish to turn on his video? Thank you so much. Harish, I think you are on mute. Can I please request you to unmute yourself?
Trying to unmute. Yes. Hi, Piyush. Yes.
Thank you so much. Over to you, Harish.
Yes. Hi. Thanks, Piyush, for this opportunity to speak. I have 10 minutes, right? Or 5 minutes to speak, Piyush.
You will have 10 minutes.
Okay. So yeah, so we are, and thanks for this opportunity, and thanks to Gauri ji for starting and kicking off this session. And she gave an overall, I mean, we're all very inspired with what Gauri ji has done in the space of energy while she was Joint Secretary MNRE, and then now as Deputy Director General of IRENA. Well, today what India needs is a very a decentralized approach to looking at energy in a manner that can actually eradicate poverty, help sustainable development, relook at consumption, and in a way where we look at a very inclusive society. The beauty of solar energy or decentralization is that it creates a level playing field. It's not only about solar energy and we have environmentally friendly, but the whole concept of sustainability is sustainable development, but also to look at sustainable development in a manner that it leads to what you call it as inclusivity of all sense, where the poor have equal opportunities to become entrepreneurs, poor have equal opportunities to become what you call it as innovators, poor have equal opportunity to have equal democratic services of health, education, livelihoods. And that's what true sustainability actually means. Many a time what we do is we look at sustainability only from a perspective of just solar panels. We don't look at, is health services being delivered in an equitable fashion for every remote villager or a slumholder to actually deliver. And that's what we should look at sustainable energy to be, as something that reaches down to the 40% poor people around the world. Because today it's an unjust world. Look at 2021. In 2021, that if 8 to 10 men own as much as 300 million people, 3 billion poor people in the world, that's something wrong. There's something wrong in which development is taking place. We just cannot look at development at one end and environment on the other end. Both are equally important. And the beauty of sustainable energies like solar or micro or winds or biogas is that it combines both. It combines both, that you don't want to hear the word sacrifice. Am I sacrificed once against the other? And so a country like India, which has 1.3 billion people, or the world, which has a population of 6 to 7 billion people, where 40% of the poor, whether it's India, whether it's Africa, whether it's Latin America, whether it's Southeast Asia, need to develop. And many a time, a lot of people are actually taking the shortcut of actually creating the same old grid system to provide electricity to them so that they can actually develop. But that's not correct, because today many of the poor have numerous aspirations, whether it's education, whether it's type of health services, whether it's type of entrepreneurship, and it's varied across. A Manipuri kid has a different aspiration to a kid from Karnataka versus a kid from Tanzania or a kid from Bangladesh elsewhere. We need to create platforms that each kid is able to reach that aspirations, that type of livelihoods, that type of health services. And so what we're basically looking at in Selco is, how do you create a platform? How do you create a platform in a manner that if somebody wants, a blacksmith blower wants to have solar for running his blower, or a silk weaver wants to have a high efficient silk weaving machine, or say sewing machine, can be solar powered remotely in the Majoli Islands of Assam, or in the jungles of Tamil Nadu, all can be possible from a decentralized perspective, that using solar. So what we've been able to do in a very, very, very small manner, that to show that sustainable energy development can actually go hand in hand. That means eradication of poverty and solutions to climate change actually can be done in one breath. And that can be done. And that gives us hope. That gives us hope that the 3 billion people who are poor, who are below the poverty line in the world, by showing how solar has actually leading them to become part of the formal sector or the formal family of the world, can actually show the upper trunks of the strata of the society that what actual sustainable living means. And universities like Plaksha can actually create appropriate ecosystems for students to rethink what sustainability means by challenging themselves to look at, if it's a dweller in Majoli Islands, or if it's a rag picker in central of Bangalore or Ahmedabad, or it is a flower plucker in Madurai or on outskirts of Ahmedabad. How can sustainable energies like solar be a part of their life, which actually leads to better incomes, better quality of life, better socio-economic, what you call as safety nets, in a manner that poor need not go back to poverty because there's some disaster. For poor, every day is a disaster, whether it's floods, whether it's strikes, whether it's increased interest rates, whether it's droughts. Can we use sustainable energy as a platform to create that nets so they don't go back to poverty? Very simple example. Like in the outer slums of Mysore, for example, there were multiple bat makers. These are cricket bat makers who live in slums, who come in from Gujarat, make cricket bats just outside of Mysore. They earn basically between 1,000 to 1,500 rupees on a monthly basis. And each of them spend around 250 to 300 rupees on kerosene on a monthly basis, which comes to approximately, if you 3,500 rupees on a yearly basis, multiplied by 5, it's 15,000 rupees. But if they had a solar system that ran for 4 hours that they needed from evening 6 to 10, if financed by a bank, would cost around 10,000. So compare yourself, 10,000 rupees for a 2-light system versus what the kerosene that they were spending, which is around 15,000 rupees. The issue was not technology. The issue was not affordability. The issue was, would the bank provide them with financing? So when we first went to the bank to provide loans for these slum dwellers, the first thing the bank said, they're not going to pay. Then what we said with 30, 40, 50 families, they said to the bank, what do you actually need? Basically, the bank said, we need 100% guarantee. So we put 100% guarantee against these 40, 50 families. And then within 6 months, when we asked the bank said they had a fantastic credit collections. So if you knew this 6 months ago, what would you have taken a guarantee from us? They said 20%. So we removed our 20% money now out. That means we used 80% money out, kept that 20% money. So effectively, the 20% got leveraged 4 times, that we could able to unlock capital. And the best answer was from the bat makers was that once they finish the loan, they'll actually either buy a sewing machine or some other machine that could increase their incomes. What they meant was they have become bankable. The beauty is now the solar system had created 2 assets. One was they owned the system, which is an asset. Second, now they were bankable, which is a second security as an asset that the people have. So the decentralized energy pushes people multiple rungs in the social financial ladder, that creates safety nets, that even if there is some sort of a disaster, they have some sort of an asset to fall back. Similarly, in Maharashtra, for example, where we always hear about these droughts and farmer suicides. Now, Decentralized energy, like say, for example, a solar powered sewing machine could actually be a backup or a second source of income for the family, that even if there is a drought, the farmer does not contemplate on going for suicide, because the family goes into, and when a farmer goes into a suicide, let's read the poor are strategized into three categories: poor, very poor, and abject poverty. Moment a farmer commits suicide, the family goes into abject poverty. It takes 2 more decades to get back to poverty. Forget the lower middle class. To reach to poverty levels itself, they take 2 decades. That's too expensive for them and too expensive for a nation as a whole. It's high time we build these safety nets that they don't have to fall through the economic ladder. So a solar powered sewing machine, or a milking machine, or a silk weaving machine can actually lessen the burden for a farmer or elsewhere, that even if there is doubt, there is plan B. And we need to relook at sustainability. Today, when people talk about solar panels, if I just put solar panels on top of your roof, does it give the right for you to actually do 20 air conditioners just because you have solar? Solar itself does not mean sustainability. Solar utilization of number of solar panels itself does not mean I'm using renewable energy, I'm great. No, absolutely, we need to rethink the way we utilize energy, the way we utilize natural resources, because if we truly have to get together and to reduce the whole threat of 2.5 degrees rise in temperatures, but more importantly for us is how do we make sure that, because the maximum brunt that climate change is having, and as you have seen in the COVID scenario, is the poor. Unless we do not tackle social sustainability today, environmental sustainability and financial sustainability have no meaning in the future, because we will keep having the disparities that is actually widening, which will lead to social unsustainability, which is critical for any district, any nation or any humanity sector to relook at what sustainability means. And that's what we need to look at my younger colleagues who are on the webinar too. It's not about that you're a mechanical engineer or an electrical engineer or MA, because the problem for us is in a country like ours or anywhere else, as we get more educated, we become more useless. We absolutely become I'm a mechanical engineer. Who cares? A tomato street vendor, tomorrow, just because the tomato prices go up, is not going to say, I'm a tomato selling expert, I'm going to sit at, if she sits at home, her three kids will go starve. She will go starving. She will have to sell potatoes. The poor diversify. But unfortunately, as we get more educated, we become experts in one field. Basically, we become useless. We don't become experts. We actually become useless. So the fact is, we need to become solution. You're not a mechanical engineer. You're not an electrical engineer. You are a solution provider. That's when you start thinking holistically. You're thinking from as if you own the problem. Today, we don't own the problem of the poor. What we do is we always come up with a solution and then we try to fit the problem. And that's not how sustainability can be actually solved. Sustainability can be solved only if you are able to own the problem and you are from the other side of the equation and say, okay, boss, I have these issues X, Y, and Z in terms of water, in terms of livelihoods, in terms of healthcare. What is the best way to lower the transaction cost of mine to get this particular healthcare delivered, this education system delivered, this type of livelihoods that I can aspire so that my family can have a decent, inclusive, and respectable living. And that's where the beauty of creating appropriate solutions, whether it's technology solutions, whether it's financial models, whether it's delivery models, asset creation for the poor. And that holistically, when you put those pieces into place, and that is where a sustainable solution comes in place, where you challenge. It's not about wants, it's about needs. And that's where sustainability comes in place. And the beauty of working in a country like India is that you have numerous problems. That means you have numerous ways to look at solutions. It's a diverse country that people keep saying it. It's diverse, not only in terms of humanity, in terms of language, in terms of culture, but it's diverse in terms of terrains. It's diverse in terms of its climatic risks. It's diverse in terms of its climatic disasters. It's diverse in terms of its flora, fauna. That means how do I have to look at sustainability in Manipur is very different to Upper Karnataka, very different to Upper Gujarat. But beauty of looking at India and being a climate solver in term truly sustainable fashion will help me to create the appropriate tools that I can then use it for any other country in the world. I go to Tanzania, I go to Philippines, I pick up pieces of what I do in Assam, mix it with what I have to do in Maharashtra, and show it to the Filipinos that this can actually be done. So India becomes a true nation of R&D of sustainability, not sustainable energy, but sustainability, where sustainable energy plays a part of that equation. And putting those pieces together, we basically say that we know what the problems of the world are. We can come up with solutions where any kid from Tanzania can learn and then make it better, that we then learn from a Tanzanian kid. And that's the only way where we start breaking country boundaries, because environmental and sustainability cannot be thought from a country boundary perspective, because you cannot stop a smoke from going where if somebody else pollutes, the monsoons are affected, not because Indian farmers have done something. World is one. And there are two wars that humanity is fighting for. That is climate change and poverty. And both can actually be solved if we are able to look at decentralized energy. But more importantly, to my young colleagues, if we can think a little more holistically, rather than just looking at financial sustainability, careers, jobs, expertise, those things don't exist. Those are very short-term band-aids. We are having a fracture. The blood is bleeding because of a fracture, and a band-aid is not going to suffice it. We need to actually operate and make sure the fracture is right. And that's what climate change and poverty is. Thank you so much. I will continue my discussion during the fire chat.
Thanks, Harish, for those inspiring stories that hold the capability to sustainably change the world. It is now time to listen to our next speaker, Amit Gupta, who is the co-founder and CEO at Yulu. He has been tackling the issues of air pollution and traffic congestion with his electric mobility solutions for first and last mile connectivity. May I now invite Amit to deliver his talk.
Hey guys, a very warm good afternoon to everyone. And thanks once again to Piyush, Anurag, Shalini for having me here. And can you see my screen now?
Yes, we can see your screen.
Perfect. So continuing on the previous sessions, my journey is also into sustainable mobility. And everything is kind of coming together as a planet, as a word. We started talking about how renewable energy, for example, is an answer for some portion of sustainability. But where actually you are going to use it, and one of the big usage of energy has been in mobility. And if you club the two equation where you are able to generate energy in a sustainable manner and use it in the mobility, so you actually solve for many other issues. So if you go back, if I just talk about mobility holistically, maybe 30, 40 years ago, this is what mobility meant to most of us. It was primarily our personal car or two-wheeler, and people were moving in the name of economic reasons or sometimes for fun and leisure. And then we know around 10 to 15 years ago, the concept of shared mobility started picking up. And that became mainstream with the help of smartphones, where on a click of a button, one can get these taxis, which are operated by drivers, etc., across the globe. And then we saw how globally there were companies like Uber, Ola, Didi, Grab, and whatnot. So they started to change the word of mobility, where the answer was, or the promise was that, hey, you don't have to have your own vehicle. You can just tap a button and I will get you A to B in no time. At the same time, we also saw that that promise of mobility did not solve for many other issues. And one of the big problem was traffic jams. So while a car moving you around from your home to office, necessarily is actually clogging the space what we have. And if you talk about India, where we actually anyway have very, very less road space with the kind of population we have got in the country, and things are not adding up. Even in Western world, where the population density is not that high as India, we actually very commonly see these kind of scenery in New York, San Francisco, Chicago, London, you name it. To make things worse, our air quality is also extremely poor. And 40% of the air pollution is caused by mobility. That's why it is right thing for us to look at these two problems in a single solution set. We don't talk about it a lot, but I know there are folks who will say that this is not real. But there are now enough and more reasons and examples where we know for sure that global warming is real. And if we don't do anything about it, we are seriously risking the existence of mankind. And last but not the least, we have been making movies and web series on pandemic, but never ever we did anything. Particularly on the front of mobility, during Corona, everything just stopped from airlines to metros to buses and taxis. We did not have an answer. That's why the new notion of mobility is not just smart and shared, it is actually more than that. And this is how I look at the new word order for mobility, which can be understood or explained with this 5S framework, where certainly this mobility has to be shared and smart. At the same time, it also needs to be sustainable. We cannot keep on burning fossil fuel to move people. And today we can talk about it, and this is not just something we have to pull out some kind of CSR budget or government funding. The good part is the renewable energy is cheaper. So we know for sure in India, the solar energy or electricity which is being produced by solar is now cheaper than the same which is being produced from our traditional thermal based power plants. So there's no reason for us to not do that. If I talk about the context of mobility, we actually have been able to get a better unit economics when we are using electric mobility versus if we were using, let's say, a petrol scooter. Answer to traffic congestion is actually unfortunately not related to sustainability, but the traffic congestion problem is solved using a small form factor. 90% of the time, you have only one passenger. More than 2/3 of the time, the person has to move below 5 kilometers. And there's no point that you are using a 2000 kilogram vehicle which is clogging out of the space just for you to move around. Not a good thing. And that's where a small form factor is the new norm or has to be new norm for the new mobility paradigm. Last but not the least, safety also an important element. So we saw how coronavirus stalled the world. We also need to have a solution where we are able to move people if there's a further instances of pandemic like situation. And if we are able to get a solution for this 5S framework, we will be a better as a planet, as a humanity. And at the same time, if you look at this whole part, so this is how when I started my Euro journey almost 3 years ago, uh, kind of thought through this equation that, okay, if we need to do this, what all elements we need to bring into the solution set, what are the things we need to do. And as an entrepreneur, what you do, you talk about these kinds of dreams or ideas to sometime prospective partners, sometime team members, and sometime investors. And the reaction back then was something like this: that they look like a good daydream, but yes, it's not going to happen in India. And if you nudge them more, why it is not possible, but yeah, it's maybe possible. When I went to this particular city in Europe, I saw how people were using these bicycles. They were on the suit, they were going to office. I also saw this, docking station. And by the way, did you forget that India has so hot and humid weather? And you're talking about all of this fancy thing is not actually going to happen. And certainly it's not going to happen in our lifetime. So we have this strong conviction that whatever we have not seen, is not going to happen soon. But as a entrepreneur, you are always about that. Okay, you are always problem first, and that's what happened with you. So what I believe that if you look at the problem set, and I must say that it is not easy for sure. At the same time, this is something which can be solved with a collective effort. So let's say if we really have to solve for all of these problems which I've mentioned, what all things do you need? You need a OEM or a vehicle manufacturer who can come and create a vehicle which is suitable for shared mobility, which are small in form factor, which can run on electric energy. You also need, by the way, battery technology, which works in Indian condition. We have a problem of lot of monsoons or lot of rains in Mumbai, and then very, very hot weather in Delhi. Most of the battery EV technology related work happened in the countries where there was no 50-degree centigrade temperature. So they never had to solve for that. The type of dust, the type of environment which we deal with. So we do need something which is made for India. Okay, you got vehicle, you probably got battery, but where will you charge it? That's where you need a charging station network also. So, and there are a lot of complexities, not trivial, but a particular battery will fit in a particular scooter or a vehicle. You need to make sure that compatibility is there. And that's where the certification and standardization can come in, where they can say that, hey, even if I never spoke about the specific size and specification, but let's use this so that we are not talking about having 100 types of sockets and 100 types of battery dissemination, and then everything will just go for a toss. There are also no policies and infrastructure. So government actually has been very forthcoming, but you do need infrastructure for services like this to happen. And last but not the least, even players who can think technology first, who can think mobile internet first, weave all of this thing together and create a service for the end consumer. So if you really look at it, it is possible for sure. But yes, you need to bring several partners and several components to come together and align on the common vision to make a progress. And if I look at things holistically, and this is actually relevant for each one of you, where probably after some part of your journey after your college, or maybe in some of you will be inspired to a startup when you are in college. It is very much possible in India, where if I talk about the small form factor part, actually India has been a two-wheeler nation. More than 80% of our vehicles are two-wheeler. So we have a established base of OEMs and people who can create those components, and most importantly, culturally, we understand how to run a two-wheeler. We also, by the way, have a very, very good solid talent. Yes, you still do not have a course on electric mobility at different colleges, engineering colleges. But good part is you do have electrical engineering, you have mechanical engineering, and I'm sure institutes like Plaksha, they will create this cross-functional or at least they will cut across the boundaries of traditional engineering and make it something which is much more solution oriented. And last but not the least, our countries are being modernized in the form of they becoming smart cities. Infra is being developed. A lot of good work is happening across 100 cities in India. And then we also have around more than 25 metro rail projects, which is also going to help moving people, a lot of people in very short amount of time, very efficiently. And this is where I believe that everything comes together. And if I talk about Yulu stories in particular, looking at the same principle I spoke about, uh, Yulu actually came up with this idea that we can probably produce some vehicle which is sustainable, small, shared, and connected. All of those things which I spoke about, and we were able to actually create this particular pedal bike, which fortunately we were able to get it done in India, uh, in Punjab itself. So designed by Yulu, it had its own IoT. It had a small solar panel. So IoT hardware was powered through solar panel, and anyone who knows how to balance two wheels can use it from point A to point B. Good part, when we put it up in Bangalore, we found many takers who were able to use that for their daily commute. But the bad part was, the distance it was actually being used for, it was only for 1.5 to 2 kilometers. If you remember, one of the pain points for India is that we have a hot and humid condition. So clearly we needed actually something which can work for 5 kilometers. And if you go beyond Delhi, so beyond Bangalore, to cities like Delhi and other northern part of the country, even far down south, this is not going to be working. So we cannot change the temperature, but what we can do, we can make something much more convenient, much more motorized. That's where we actually introduced this product called Euro Miracle. I don't know how many of you have seen it. We are pretty popular in Delhi, Bangalore, Mumbai, and this product actually was created for shared mobility, and it is one of the, I think, easiest to learn and use, and very fun drive experience. And we were able to pull it off just because of the conviction we had in the business and the problem statement. Not only that, we also created a whole network of parking stations. So we have close to now 3,000 such parking stations where people can pick up these vehicles and put it back. So particularly, for example, in Delhi, each a lot part portion of Delhi, we have actually tied up with Delhi Metro, and they have given these spaces. We also have these Yulu zones, as we say, at shopping malls, offices, complexes, residential areas, so that someone who needs to use a vehicle for A to B commute, they can use this vehicle. We also created our own hardware for charging stations. We have been able to put them at mom and pop stores. So today we have more than 110 charging stations, probably the largest charging station network in the country. And even from the vehicle perspective, we are now the largest EV company in the country, with 10,000 vehicles on the road. And we think that while this number in isolation is a very small number, and that's where we think that the journey just started for us. We started making a lot of impact on the climate in terms of carbon saving, in terms of the number of commutes which we are able to replace from a fossil fuel vehicle to Euro service, and also creating a lot of jobs in this process. So we think that it is not a difficult thing. It's all about someone's conviction that what all things you can do, and things will just follow after that. And interestingly, as an entrepreneur, uh, we believe that this problem was worth solving, and at least with our effort, we have been able to show a ray of hope to everyone that this problem can be solved and there's a template. So this is how I look at it. You know, this is how journey started. In the beginning, only few takers who were just trying to be sustainable, use sustainable mobility. They were haggling with traffic, a lot of challenges. And then more and more people started seeing value. They started using Yudo. And as you can see, the cities started becoming greener, lesser cars. People were using services like Yulu and Metro and clean buses. And this is how our country actually will become a much cleaner, and we will have a sustainable future. That's all I have. Thank you. So Piyush, over to you.
Yes. May I request Shalini ma'am to please come and moderate the session? Thank you.
I'm not, yeah. Thank you, Harish and Amit. It was absolutely wonderful to listen to your stories. And I'm going to pose just 2 or 3 questions to each of you to help learn more from your experiences. So going to Harish first. And Harish, you talked and emphasized a lot on the productive use of energy and the productive use of solar in specific, that unless there is a secondary or productive use, it's not an end-to-end solution. So the energy is not an end in itself unless it is put to some productive use. And also you talked about how the credit guarantee and credit worthiness was increased despite the fact that they were spending about 15,000 rupees on kerosene before, and then 10,000 was the use of investment of the home lighting system. Share with us what are the other examples that you would like to share with our audience today, which is industry, think tanks, and academia, besides this energy and lighting option, where they can take these quick wins, especially where the unjust world has become wider.
See, it's not only lighting, as you said. I mean, in the productivity, I gave an example of lighting, but there are numerous. For example, we've created these livelihood centers where you can actually have common owned by FPOs, farmer producing organizations, where it could be a turmeric grinder, it could be a chili grinder, it could be a roti rolling machine, which is all run on solar and owned by the FPO. So there are opportunities for efficiency of a chili grinder or a swing. As we were speaking last time, Shalini, the issue is when we design solar for a chili grinder or solar for a swing machine, solar gets blamed to be expensive. Nobody talks about inefficiency of the chili grinder or a turmeric grinder as well as the swing machine. The inefficiency of those products actually forces people to rely on grid power. So the best friend of grid is inefficiency. And so had these products, if the industries who actually produce the motors, and especially for the people in the marginalized spaces who like they earn their livings through silk weaving machines, roti rolling machines, etc. So lathe machines, bakeries, small bakeries, the pressure pumps at motorcycle repair shops, all are inefficient, extremely inefficiently designed, and the operational costs that the poor have to bear is actually expensive. So the capex might be kind of cheap, but the opex, because of electricity or diesel generators, hugely expensive. And so industry has a huge role to play in efficiency. And unfortunately, the industry is so targeted towards the upper strata of 20%. How do I make LED lights? How do I make washing machines more efficient? How do I make smart TVs and say that my TV only spends 60 watts? That's ridiculous. I think we need to have what does the bottom 40-45% of the population, which has to come to the next level of incomes, that efficiency is what the industry, the banks, the financial institutions. We had the green revolution many years ago. Now it's high time we had the income equity of income generating revolution to happen.
Yeah. And Harish, thank you very much. And you have, actually lived one of the best models where you have helped the producer or the consumer participate in the design. And I think that has been one of those very rare experiences. In fact, you've kind of challenged that fortune lies at the bottom of the pyramid by actually calling it a vulgar phrase. Share with us more on that, especially the examples that we've often talked about, like mini grid. On one hand, the viability of the mini grid, grid is going to be effective as we have more and more appliances? And in the end, are we encouraging consumption, or are we tackling the question of viability of the mini grid? So I'll leave it at that.
Yes, I mean, it's yeah. When people talk about it, see, the thing is that on inequity, when we talk about equity, but unfortunately, all the business models is in fact on a pure Excel sheet is always extractive, and it's not from a left leaning thinking at all. It's show me on an Excel sheet and I'll prove it to you. It's extractive, right? In a sense, a 1 rupee sachet. And let's look at an Excel sheet, and who captures most of the money in a 1 rupee sachet? It's the shareholder and the company. It's a zero value to the poor, because it's a 1 rupee sachet of a shampoo which absolutely has no income generation. It's absolutely of no need. It has gone to the whole shareholding pattern. Same thing like microgrids. When people talk about financial viability, they always talk about financial viability from the supply side, never from the demand side. And it's always, okay, I'm going to put in electricity. Now I can see how can people use more and more, so my microgrid becomes viable. It's never about the end user becoming viable. What does the end user need? How do I design systems that the end user can actually live an equitable life of dignity? And in many cases, Shalini, you know that many of the people who work during daytime, I don't need lighting during daytime, but unfortunately, because my house is so poorly designed, I'm forced to use microgrid. I could have actually made a hole in the roof and put a glass tile, and actually the lighting would have been enough. But no, wait, I have microgrid. You need to pay me for that. So the question is, it's a design thinking, is we do not put ourselves in the shoes of the poor and design. It's all about one part of the equation, taking all the financial resources. And that's, I think, sustainable energy pushes that back of decentralization.
Yeah. And Harish, with that, I want to ask you the last question on the reverse supply chain that you've often talked about to ensure the social sustainability, environment sustainability, and financial sustainability from the consumer's perspective.
Yes, I mean, if you look at, we always look at supply and the wordings also, Shalini, and Amit Saab had brilliantly put it. But my question is I mean, just to give it from a transportation analogy, right? When the poor man cycles for 365 days, it's called poverty. When a rich man cycles, it's sustainability, right? In a sense, and then in Bangalore, before you came in, actually, when the rich started cycling, you created cycle lanes. When the poor started cycling, hard jao road se, you're wasting the time, right? This concept of when numerous poor areas do cycling, but that's the concept of sustainability is always looked from the upper middle class perspective. And that is when we always, our thinking process, we are always taught sustainability from our side. And that's exactly, I'm so glad that the universities like yours, Plaksha, would basically reverse that and say, boss, don't come up with a solution. Do you own the problem first? If you own the problem, and that is when I start looking at the reverse side, am I socially and financially sustainable? That if you look at from a poor man's perspective, you don't actually have to talk about environmental sustainability. Because the most effective way to make the poor financially and socially sustainably, it's no other solution but environment solution actually plays a role.
Thank you, Harish. And, we can go on talking, and I know that I'm always very inspired to listen to you. But on that very note, on that very segue, I want to go to Amit. And Amit, help me understand how we can change the narrative of, the poor man cycling, milkman using the cycle, or the dhobi using the cycle, to make it the cool guys using the cycle, from film stars to sports stars or and making a way of life, not for sports activity or fitness activity, for daily commute. So how do we change behavioral change and the narrative besides the technology and the ease of use?
So very good question, Shalini. And in fact, when I started this YOLO journey, that was the most difficult question which I had. you can fix all of that problem I spoke about. You can innovate by, these bikes and IoT and whatnot. But how do you change the mindset of an individual? That is the very, very difficult point. But what we knew for sure that there are certain pain points which are also real, which are not related to a financial status of a person. I'll tell you about my own use case. Before, by the way, Yulu, I was with Inmobi, where my home and office, they were like 2.5 kilometer. And when I moved to this office and home setup, I used to spend 7 minutes in traveling from home to office in my car. That 7 minutes started becoming like 35 minutes, 40 minutes, sometimes 50 minutes if I'm not lucky. And then I'm like, okay. And that's how my own life journey, I was turning 40. I was like, okay, what should I do? If there's something else which I don't do today, I'll regret after 10 years. So I started to think about the problem, and I ended up picking the mobility problem because I thought that there are several entrepreneurs who are solving for education, healthcare. But what is one problem which is impacting me as an individual, irrespective of my age, gender, and financial status? And it happened to be the air which I breathe and the road which I use, right? So if I want to now save time, I have no choice but to move to something like a bicycle or something which is, friendly enough, where I'm not basically getting stuck. And the second point was, and I'll actually steal something from Harish's side, he actually mentioned design thinking. You don't give a lousy product to a current generation person. He will not be feeling, encouraged. So you create a product which is so vulnerable, where someone will say, yeah, you know what, I'm not being stereotyped. If I'm using this bike or this vehicle, I will look cool. I will look a person, an ambassador for sustainability. I'm okay. I'm not a poor person. I should not feel bad about it. But I'm waving a flag where I'm making world better. This emotion of you becoming a change agent actually clicked in our favor. In fact, Yulu's tagline in the beginning, we were like, our tagline was write the change, pedal the change. And we promoted our brand in a manner where people were inspired and they were feeling cool. You actually will be very surprised. We probably are the only mobility company which will have the maximum number of Instagram posts by the users. We are one of the most Instagrammable mobility product in the country after maybe airplanes. And why it happened? Because we created this cool design and aura of using Yulu and people feeling great about using it. So it's a combination of, and at the same time, we didn't want to make it for elite. We wanted to make this service for the normal people. That's why even we believe in equitability and inclusiveness along with the sustainability in our solution. So at 8 rupees per kilometer, which is cheaper than auto rickshaw, we are able to move people in a product where you feel, oh, I'm using a 21st century product and it looks cool. And I have no notion that, oh, this is being used by a security guard or a dhobi or a milkman. And we do have those users also. So it's a kind of a Amul brand, which is my inspiration, where everyone from we guys to a person who is a help for me, they're also using Amul. But see how they have created persona around their brand. So this is where we basically got our inspiration, and we are very glad that so far our journey, touchwood, we have been able to solve for that perception problem also.
Thank you, Amit. And my last question to you is that while the narrative has to change, while the ease of use has to happen, while the technology has to be useful and not like the initial, I remember solar was rejected because of the poor technology, and then it went through various iterations till it became effective and it became advanced. So is it what helps and enables the adoption? Is it technology, platforms? Is it policy, infrastructure? Is it the narrative, the storyline? Is it the context, which is India, where you talk about the climate and dedicated infrastructure, etc.? Or what comes first and what helps adoption?
Yeah, I think each one of these line items actually are helping each other. But there's one thing where I think which can help things dramatically for a great adoption is the infrastructure. So we saw how China they created dedicated lanes for these low speed vehicles and bicycles, and people started moving from their cars and another form factor to this kind of form of mobility. We are also seeing after pandemic the cities who were not very keen on adopting to these micro mobility solutions, such as Paris, New York City, even London, there was a lot of resistance. But what they did, they did a survey, and everyone was like, I'm not going to use public transportation. And cities, they were very afraid of everyone buying their own car because they can afford it. And they moving 10 steps back because cities will be further clogged. And with the vision of Paris mayor, for example, 15-minute city, it's not going to happen if everyone start coming in their car. And that's where they said, okay, I'm going to create this dedicated lanes for bicycles and e-bikes, etc., along with favorable policies that if you, by the way, using e-bike, there's a 500 euro incentive for you just towards maintenance. Or if you are buying this, I will give you reduction in income tax. So several things came together along with a big mindset change from the consumer, where in the past, I will be very honest, people were like, okay, I need to go from A to B. I don't care whether the vehicle is electric or not. But after Corona, and we have proof points with survey where people are saying, no, I have a very strong preference for a greener mobility solution. If you give me in my price point, I will prefer that. So a lot of things have changed. But to your point, the biggest number one lever where 10x impact can happen is a dedicated infrastructure for this kind of service where people will feel confident and safe, and everyone then move towards that in no time.
Thank you very much. And I have my last question for both of you together, and whoever can start first. And that is, what is your one strong, quick win advice to our audience, which is again industry, think tank, and academia? Harish or Amit, whoever wants to go first.
Harish, please go ahead.
To the industry and all, be serious in what you're saying. And we don't have time. And so I think X amount of the industry, there is, I don't want to use the word, Shalini, opportunity. The opportunities are there. The industry is not looking for it. And industry needs to be serious, because industry is one of the flagship stakeholders for sustainable development. It's not the question about only financial. They will have financial gains, but they need to create product lines that are. So, I mean, if you have a correct product line, Shalini ji, you don't need to have CSRs. So yeah, I think it's your normal business should be social responsibility, and then I think should be serious. That I would like to really take on the industry to be. They are the main stakeholder to push this to happen, and they can make it happen more than anybody else.
I think from my side, I have lesser complaints from the industry. I think we have far more talented people in our country and running those ships. I think if we have to fix something, it's actually certainty of the policy. If we say that this policy is being made, we make sure that we execute and we stick to that. There's no change in hearts. Like solar energy, sometimes rooftop is there, sometimes is not there. And this is not good. People and industries are putting billions of dollars of investment, and suddenly, the change in policy, that's not good. And my request, and I hope more than request, more, hope institution like yours, you should come make intersections of these solution sets, enough of mechanical engineer and electric engineer and doctors sitting in their silos. We need to bring people together and make it solution oriented, because that's where we solve problem in India, for India, by Indians. And we should not be looking at the Western world that they will come and kind of bless us with their solution set. No, we need our own people focused on our own on problem set and solve for that. So I'm very excited about your own journey, Plaksha's journey, and I would like to see maybe 100 more Plakshas coming together, bringing people the brightest mind with interdisciplinary approach and solving one problem at a time. And we will a different country in no time. So that's my aspiration and my hope and wish for your institution.
Thank you very much. That's exactly the intent to bring academia, think tanks, entrepreneurs, government policymakers all together to be able to create an interdisciplinary solution. So with that, I hand it back and thank my speakers again. Piyush, over to you.
Thank you.
Thanks a lot, Shalini, Harish, and Amit, for those interesting insights. I'm sure our audiences would have been inspired by a conversation around bringing a positive change in Indian society using clean energy resources. We have been fortunate to be supported in this endeavor by our cordial partners, AEEE, Business World, Economic Times, Savi, and US ISPF. We now have a video from AEEE on their approach towards enabling clean energy transition.
India's climate change policy document talks about the need for energy efficiency and the role it can play to significantly reduce its energy intensity by up to 33%. Energy sufficiency and energy efficiency are very closely intertwined. At AEEE, we believe that energy efficiency is the cheapest, fastest, and cleanest resource to make this energy transition.
Before we move into our next session, we have a very interesting poll for our audiences. Can we have the poll on the screen, please? I would like to request our audiences to choose their response to the question on the screen. Let us look at what our audience think about this poll. It looks like most of our audience are confident about the role of deep tech in clean energy transition, which is a great thing to know. So, we have heard incredible stories and the potential of digital technology in catalyzing clean energy transition. Let us now hear from industry leaders in the sector about the efforts required to efficiently utilize advances in digital space. We have a panel discussion that will be moderated by Devarajan Srinivasan, co-founder and CEO at Poundra LLC. I would now like to invite Dr. Srinivasan to the Zoom podium and moderate this panel discussion along with our stellar panelists. Over to you, Dr. Srinivasan.
Thanks, Piyush. Can you hear me?
Yes, we can hear you.
Perfect. Well, warm welcome to everyone to this panel session. Our panel topic today is digital technology in the global energy transition. Real brief, digital technology, as is well established, is changing all aspects of our life, right? In the ways we work, travel, and play. Particularly in the energy sector, it is enabling a global energy transition. And what this transition is doing is it's enhancing safety in energy for our workers and the public. It's encouraging sustainable generation and the sustainable use of energy. It's extending accessibility to energy, and it's improving productivity, right? And these have come about because of digital technology and digitalization advances that have led to the development of new and smarter sensor technologies for energy. And it has also led to widespread and increasing use of deep tech, like the poll we just saw, like AI, ML, and blockchain. From the energy perspective, some of the most visible aspects of this energy transition that you can see are the remarkable increase in distributed energy resources and many new ways of consuming energy. In addition to the visible, behind the scenes in the energy sector, the transition is occurring across the entire sector, starting from generation through transmission and distribution, what we call the grid, and to the end use of energy. So for example, in the generation sector, we have seen increased use of renewable resources like solar, wind, geothermal, and biomass, specifically in India. And advanced analytics using AI ML is being deployed to reduce costs and improve performance. On the grid side, as I said, behind the scenes, digitalization has vastly improved situational awareness. It's given us a richer, deeper understanding of what is going on the grid, things like voltage profiles, power flow, locating faults. And this has resulted in improved safety and better reliability on the grid. And lastly, in the end use sectors, we have industry, buildings, transportation, digital technology, such as big data analytics, IoT. They're increasing energy efficiency using some tools like automation, intelligent building systems, and advanced process control with smart sensors. So the adoption of digital technology, right, in what has traditionally been a very conservative industry, has also resulted, of course, in new challenges and risks, right? And alternatively, think of them as new opportunities, as it is commonly called in industry. Some examples of these risks include cyber physical security, privacy risks, and a very real disruption of established technology and markets. Considering energy, right, the severity of these risks and therefore the consequences are substantial. You have to consider how deeply energy is embedded into all aspects of life on our planet. So in addition to technical solutions that may address these opportunities, we also need completely new policy frameworks, new market and business models, and new financial instruments. So moving forward, it is my honor and pleasure to introduce three very distinguished energy professionals. Mr. Manoj Kohli is Country Head of SoftBank India. Mr. Frederick Goodemel is Senior VP at Schneider Electric. And Dr. Praveer Sinha is CEO of Tata Power. So I am going to go through some brief bios of our three speakers, and then I will turn it over to them. So Mr. Manoj Kohli is Country Head, SoftBank India of SoftBank Group International, and is responsible for addressing government, regulatory, and public policy issues. He supports portfolios of over 20 companies at SoftBank Group and SoftBank Vision Fund. He has developed over 7 gigawatts of solar, wind, and hybrid projects. And in his career spanning over 41 years, he has worked in the manufacturing, telecom, renewable energy, and now the digital sectors. Mr. Kohli has worked in the US, Europe, China, Japan, and has built businesses in more than 20 countries in Asia and Africa. He's serving as the chairman of the Future Business Group at CII, which is the Confederation of Indian Industry, and is responsible for attracting major investments into India. Amongst his awards, he has received the 2000 Telecom Man of the Year from Media Trans Asia, and the 2004 Telecom Person of the Year and the 2020 Lifetime Achievement Award from Voice and Data. Mr. Frederick Goodemel is the Executive Vice President for Power Systems and Services. one of the largest business units in Schneider Electric. Frederick joined Schneider in 1990 and developed his international career around the power domain, spanning across low and medium voltage, energy automation, infrastructure, and services. He has served in global as well as operational leadership roles based out of China, UAE, and currently in France. Frederick holds a degree in engineering from the École Centrale de Nantes from France and an MBA from ESSEC, also in France. Our third panelist is Dr. Praveer Sinha. He's the CEO and Managing Director of the Tata Power Company, India's largest integrated power utility. He has 36 years of experience in power generation, distribution, setting up various greenfield and brownfield power plants in India and abroad. Dr. Sinha is extremely passionate about the inclusive growth of society. He has implemented numerous sustainable programs that focus on women empowerment and skill development for youth, with nearly 7 lakh beneficiaries in our nation's capital. Dr. Sinha is a qualified electrical engineer. He has a PhD from IIT Delhi, a master's in business law from the National Law University in Bengaluru. He's a visiting research associate at MIT and distinguished visiting scholar at Faculty of Engineering and Architectural Sciences at Ryerson University in Canada. So without further ado, as they say, I invite Mr. Manoj Kohli. He's going to talk about technology for the clean energy transition. So over to you, Mr. Kohli.
Thank you, Srinivas. Grateful for inviting me to the session. I think today's session is a very important theme because globally clean energy is the most important, single most important theme of the world. And that's why as Biden took over, on the first day, maybe the first order he signed was on clean energy. Clearly means that this is a serious priority across the world, and countries which do not prioritize it will definitely have to pay the price for it. However, from a fossil world to a clean world or a renewable energy world, there will be a transition. And this transition is going to be not a small one. It's a huge global transformation. Not like anyone. For example, I participated and led transformation from landlines to mobile internet, which was quite big and quite global, but still not as big as this. This will be far bigger because not only it will cover the power sector, but now it will cover the transport sector also because of EVs. And of course, it will take a couple of decades at least, maybe till 2040. But I think it will be very crucial for our future generations. Now, this has to be led by technologies. It is all 100% technology-led transformation, whether it is solar technology, wind technology, and of course, digital technology being the catalyst behind it. I believe that the technology orientation of this transformation will lead to not only it being high quality, but also being affordable. Generally, it is seen that the new technology is seen as more expensive, but in this case, the new technology will be much more affordable than fossil, whether it is for our energy needs or our transport needs. Now, the renewable energy is intermittent in its nature, and that is where the problem is. But it's very important that in the transition, renewable energy is blended with the fossil energy, with the thermal energy, and to make it RTC, round the clock, 24/7. And that can only be achieved through digital transformation, digital methodologies. And I believe that the digital technologies will catalyze at least 4 or 5 big parts of this transformation. And let me share those with you. Number one, it'll, as I said, combine renewable energy with fossil till the cost of storage is affordable. And it'll do this through smart grid, interacting with smart grid and making it easy for it to be blended. Number two, the maintenance. The maintenance of our plant we generate clearly need proactive health management of the equipments. And very frankly, the manual maintenance is behind us. It is past history. The future maintenance will be digitally controlled, as it is in many other sectors. Number three will be forecasting. Forecasting of power, forecasting of energy needs, consumption, grid planning, very importantly controlled by digital technology and a digital forecasting methodology. Then load management, load planning, and that can definitely get smarter through digital technology, time shifted methodologies, and definitely for the lower price for the consumer. And also finally, the EV charging, smart EV charging can happen when the rates are low. And that can only happen again by an intelligent system supported by digital technology. Now you will say, how much will digital technology do? It will do end-to-end. This transformation will be made easier, convenient, and precise through the digital technology, because AI is much smarter than human intelligence. And it is much more precise than human intelligence. So for example, to forecast when there are clouds. For example, when you have hailstorms, to forecast what kind of power you will get at lower level, how will you blend, how will you maintain stability. So many factors, so many variable factors can only be stabilized by support of digital technology to the energy transformation. So I believe that actually the renewable energy transformation will be very solidly supported by digital technology so that this transformation remains smooth, convenient, easy, and affordable for the lowest strata of society across the world. So Srinivas, that is my thought around this theme.
Thank you very much, Manoj. At the end of all three of our speakers, we'll have a brief question and answer session. So I would now like to invite Frederick Goodmill. Frederick will be talking on smart energy solutions for a better world.
Yeah. And first, a big thanks to invite me and welcome me to speak to this audience. And there is a set of common themes compared to what Mr. Manoj was saying before, on which I'm gonna reinforce probably with the angle of a manufacturer, but just illustrating how solutions can now allow to do things on a different way. So if we start by the overall energy equation and we look at what the energy future should be, we see the combination of two things: electricity, and I'll come back on why electricity is important in the energy challenge, right? Because we may look at electricity as only one source of energy, but finally, it is the more sustainable source of energy. And combine electricity with digital, using a combination of technology and setup, is really the right way to build a world that will be first more sustainable and second more resilient, right? And I think the two topics are of importance in those days, because we may not be able in those days to access to all the installations we would like to access to. there is a set of constraints to travel. So resilience is becoming a key topic as well. Let's start by electricity, right? If we want to decarbonize the world, electricity is really the solution. It is from far the cleanest form of energy, and it is the most flexible one, right? So I'm not dreaming that we have only electricity as the only source of energy. I know there is a lot of work on hydrogen, green hydrogen, and so on. But basically, for all the usage that requires flexibility and that are not for heavy industry, electricity is the solution. Reason is that it can first be decarbonized at the generation part, right, with renewable. And here I have to pledge the effort that is done in India, especially, to increase the capacity of renewable. Some may say it's intermittent. This was a debate of the past. We are able today to cope with intermittency of renewable, and we start to have affordable solutions to manage this intermittency. And the second thing, if you look down the road at the usage level, electricity as well is the solution to bring flexibility for building, for residential applications, for offices, for light industries. That means using electricity is basically the solution. So let's start by that, but let's look why we need to add digital to electricity. So I'm going to go along the chain that you know, generation, distribution, and demand, right? And if you look along this chain, you have here a few data points on which you see what's happening to each of the stages. I spoke about generation, where basically we will have much more generation from renewable. And in order to manage the variances, you need to have digital technologies. Manoj was speaking about asset management. It's quite obvious that in the future, you can look to have less people on site and do much more things using technology and remote management of your operation. Now, if you look at the grid, in order to integrate these flexibilities that renewable is bringing, and in order to cope with the flexibility of the demand that is more and more high, because you know that in many countries now we're introducing electrical vehicle, and it makes the curve of demand even more extreme, I would say. In order to cope with this flexibility, we need to automatize transmission and distribution grid. Well, transmission was automatized since long, right? Distribution was not that much automatized, but most of the renewable are injecting directly on the distribution network. So we need to make the distribution network more flexible. Another line of thought on distribution is that we can decarbonize a lot of what we were doing at this stage. We can have less losses, we can use equipment that are greener, and we can, of course, recycle equipment, so build a circular economy around what we do on the grid part. And let's look at the demand side. Demand side will be different tomorrow. There will be more of what we call prosumer, means producer and consumer at the same site, with microgrid, with communities that are around energy and that want to make their local production, but none of them will go into a place where they will isolate from the grid. So we need to connect the demand side with the grid and with the generation. Digital is the only solution that allows to connect those three domains. We will not be able to do the entire efficiency along this chain if we don't connect them through digital. So as much as we have spoke about data lakes, we will speak about digital connection between generation and demand through the grid. In Schneider, we built solutions to be able to do this integration, and we patented what we call EcoStructure, which is a set of data that are common so that demand, renewable, digital, and equipments are connected and exchanging key data in a single format. If now we move a bit to some example, I wanted to give to the audience a few examples of utilities that have used technologies either to save a lot of energy and optimize their grid, and this energy being available for better usage, so is less coal emission, either to decarbonize their product on the chain using some energies which are without a gas that is hexafluoride sulfide fluoride, that is a very good gas for electricity, but not very safe for the environment, and that we aim at replacing in a common future. So in order to conclude on my speech, I think what we all have to drive now is somehow taking control of this new environment, what we call the new electric world, in which there is much more connection between the generation side, the distribution side, and the demand side, right? In order to build a future that is more sustainable. And for all, sustainability is not only driving financial performance, it starts to drive, obviously, customer loyalty, because customers are very concerned about sustainability. And it drives as well talents, means people, young talents, are today looking at companies in which, of course, there is a business to do, but there is a purpose for life. I believe sustainability can be a good purpose for life for people entering in our companies in the future. So that was my main points. Over to you and ready for future questions.
Thank you very much, Frederick. Next, we move to Praveer Sinha. Dr. Sinha, over to you.
Thank you, Mr. Devarajan, and thank you for Plaksha Center for Clean Energy for the invitation. The topic, digital transformation in energy, I think very relevant topic, and let me try to put it in perspective. What we have seen globally, that three big changes have happened, and this is for the first time in last 100 years that we are seeing this sort of a change. The first is the decarbonization. That means there is a method of producing energy other than the way it was being produced earlier, where we had the coal-based and gas-based hydropower plants, and of course nuclear. So there is an opportunity now that one can go fully decarbonized, and many companies and countries are on that path. The second is the decentralization. The decarbonization also gives the opportunity to have distributed generation. And what does that mean? That means that you can generate electricity at a distributed location. There is no need to have large generating plants, large transmission systems, and then the distribution system. You can generate it in cities, you can generate it in rural areas, microgrids are there, in cities you can have the rooftop solar, and you can generate it in various parts which are the load centers. So there's no need to really create large infrastructure at places which are thousands of miles away, and to that extent it empowers consumer, and it also means that there is an opportunity that every person can become a consumer of electricity as well as a producer, and in today's context they are called the prosumers. So that's a very, very important change, the empowerment that has come to the people, and they need not always be dependent on others for generating electricity and supplying to them. And to facilitate all this, the big change that has happened is the digitalization. How digital technology today is helping you to provide data and information on real-time basis. We earlier had unidirectional flow of energy. Now we have the bidirectional flow of energy because of the decentralized generation. Now, along with the flow of electrons, there is flow of data that is taking place. And the data flow is happening on real-time basis or near real-time basis. So that means that you know exactly how much of energy is being consumed in different locations. And what is the real benefit of this? The real benefit is that you can now monitor and manage that, control the load that is there. And there is no necessity of creating huge backup supplies which used to be there, and then backup transmission system and backup distribution, because on a real-time basis you can do a much better understanding of how much is the load and can digital technology help you in also deciding that what sort of load you can have. That means, can you empower the consumer by telling them that how they can move their load from peak hours to off-peak hours, or from off-peak hours to some other hours where some of the unimportant or non-critical loads can be utilized during those periods. So that's the beauty of the digital technology, whereby it is giving you information. Now, Manoj was mentioning that how do you manage and some of the digital technology solutions. So, as a utility, on a real-time basis in the Indian context, every 15 minutes the load pattern changes, and the day is divided into 96 slots of 15 minutes each. Now, on every 15-minute slot, you can decide what will be your energy. The energy depends on few factors. One of the biggest factors is the weather. Now, the climatic changes which are happening, there will be cloud cover, there will be wind, there will be rain. How you get information on real-time basis and create a solution. Now, the algorithm that you will create will be dependent on the local area, the utilization of energy that takes place. It depends not only on weather conditions, but also the location where it is. It depends on also the weekly hours or weekly days on which certain offices are working. So typically Saturday, Sunday, the commercial offices are closed, but the industrial load continues to be there. Similarly, many of the locations you will have markets which are closed on different days of the week. So how do you plug all these things in terms of an algorithm? And that's where the artificial intelligence and the data analytics comes and plays a very, very critical role. The second area that you can handle this is by, again, telling the consumers how to manage their load. Now, these are solutions today which are known as the demand response solutions, whereby you facilitate the consumer to manage their load in such a way so that their peak requirement of power are shifted to the off peak. And this will become more and more common in future when we will have e-mobility, because you will have electric vehicles which will require to be charged. There are certain hours of the day when you would like them to use the network for charging their vehicle, but there are certain hours which you will not like them to use for charging of vehicles, because those are the times when everything is working. Like in a city of Delhi, the peak time of power consumption is between, in summer months typically, is between 3 to 5, and then again in the night there is another peak which is there. Now, if it is 3 to 5, can you ask some of your consumers, and especially the consumers who are having large load, that they switch off their ACs during this certain period of time, and or increase the temperature from say 18 or 20 degree to 24 or 26 degree, or run some of your facilities partially. Like in Delhi, we tried working with Delhi Metro and said that you do not have peak traffic during that period. The number of footfalls is much less between 3 and 4:30. So can you run only few of your escalators and elevators? Can you reduce your temperature of the air conditioning system? Similarly, in shopping malls, where you do not have peak number of consumers coming into during the afternoon time. So there are today, digital technology is helping you in getting this information on real-time basis and managing your load. And I think many of the solutions today that will come in doing the network planning, as well as doing a load forecasting and demand forecasting, will use digital technology. And many of the solutions, whether we are talking of data analytics or the artificial intelligence solutions, those solutions will be utilized for coming up with optimized design. We also find that today, with more and more renewable penetration, and also in terms of whole lot of automation and digital technology coming in, you can have a much better line of sight in terms of how to utilize your equipment. Through analytics, real-time analytics, you can do real-time monitoring of your equipment, whether it is renewable projects or it is your conventional projects. You have sensors today and IoTs, which give you again information on real-time basis on the characteristics of the utilization of these equipments. In case through analytics and through the algorithms that can be developed, you can figure out that which of the equipments require replacement or requires to be repaired. So I think the technology that has come today, and especially the usage of data, is helping today utilities as well as consumers in getting not only information on real-time basis, but also in terms of ensuring that the reliability of supply improves. Let me now come to the consumer part of it. What is the great benefit to the consumer? Starting from getting a connection where you don't have to go to the utility. Sitting at your home, you can make an application, you can make the payment, and you can get the connection. And on real, and information will be given when they will come and give you the new connection, and what time you should be available at home when they will come and put the new meter. To the stage of getting information on what is your billing. And again, in this, there are a whole lot of solutions that can come. You can provide information on the billing pattern of the consumer. You can provide them information as to how much of the consumption that they have done from the first of the month till that day or till the previous day. If you consume electricity at the same pace, will you cross the slab in which you are getting your supply? For industrial and commercial loads, there is an aspect of power factor and the reactive power that you have. How much of penalty you are paying because of the reactive power, and can you do something by putting more capacitors in the network to ensure that you do not pay any penalty on reactive power. So whole lot of information comes to the consumer, and consumer to that extent is in a much better way they can manage their consumption as also manage the amount of money that they spend. So for the consumer, it is sheer pleasure today to get information on real-time basis and monitor. It also helps the consumer to decide in terms of what sort of energy they can use. I keep on saying that today you have a menu that you will say that I will only use renewable energy, and you don't have to use any conventional energy. Those solutions are also now getting available. And I'm sure with more and more regulatory support that will come in and with policy changes which are happening, people can take a choice that I will only use energy from renewable sources and I will not use any of the conventional energy sources. Similarly, they can decide that I'm consuming so much of energy, and if I use the highly efficient air conditioners or refrigerators, my consumption of energy can come down. And this data also can be provided to the consumers, whereby they can make out that how much of consumption they want to do and how energy efficient they want to become. Lastly, because of the signature analysis that can be done of the consumption, one can figure out that what sort of equipments are being used in the houses and what time and how many hours of usage is taken by the consumer. So I think the opportunities which are coming are tremendous. This is a great phase whereby the integration or the merger of electrical energy with digital technology has happened. And with more and more new technologies and more IoTs and the data analytics, one will be in a much better position to not only manage their load, but also monitor it and optimize it. So I think we are in a very exciting phase. This is a phase which the power sector had never seen it in last more than 120 years since the time Thomas Alva Edison found electricity. And I think this is an area of great research and innovation that can be carried out. So I'll stop over here, Srinivasan, and look forward for some questions and interesting discussion.
Thank you, Praveer. Thank you, everybody. This was very enlightening, right? And also very satisfying All three of you have emphasized several things. One is that there is a transition. It is across all sectors and it is global, and that digital technology is playing a huge part in this. So, this also kind of validates where Plaksha and the Plaksha Center for Clean Energy is putting its efforts in. So thank you for that. It's really good to get validation from industry experts. I have some questions that we can go through, and then when the audience was asked to register, they submitted some questions, so we will go through that, and then also there is a live Q&A. So I encourage the participants to please type in your answers in the questions in the Q&A, and we will try to get them answered. So let me start off with Mr. Kohli. Actually, I'd like to ask a generic question, a theme that came up quite often to all three of you. Everybody understands the benefits of digital technology, right? It's becoming more and more clear. But people are clamoring to go more and more green and sustainable. So in your business and industry, have you seen, or do you have any examples of where digital technology specifically helped a company, either yours or others, become more green? So I'll start with you, Mr. Kohli. Manoj, you're muted.
Yeah, thank you, Srinivasan. Digital technology is all pervasive. And as Praveer said, we are seeing consumer behavior change dramatically in the last 10 months towards digital behavior, digital transactions, banking transactions, online shopping. So in 10 months, I think the consumer behavior has taken a leap of 10 years. Now, and hence it is a catalyst to every industry. We at SoftBank, like in India, we have about 25 companies which I support. And each of them are leveraging digital technology for all industries. For example, Ola and Uber do it for transport. Paytm does it for financial transactions. Grofers does it for grocery. Oyo does it for tourism. Lenskart does it for IKEA, and so on and so forth. So I believe that energy sector will have the maximum flexibility, user friendliness, and ability to change at a short notice, modify, change. For example, EVs. What time should we recharge the EVs? What is the best price, best cost at that time? Maybe we can recharge at the time when the load is low. All that can be very well controlled by AI-led charging stations. The charging stations will have intelligence of that entire cost as well as the load factor. For example, Ola is launching Ola Electric, which is a new company of Ola. And Ola Electric is getting into electric two-wheeler, electric three-wheeler, and electric affordable four-wheeler. And they're also trying to utilize this methodology, not only for manufacturing of these EVs, but also for recharging, etc. So the point I'm making is everyone, all companies, at least SoftBank Group, we are encouraging all companies who go digital and go green, because both these will go hand in hand, and digital technology will expedite going green. It will be easier and faster to go green through digital technology support, because you get artificial intelligence support, you get digital machine learning support, where the intelligence is added to your system very, very swiftly. So I believe these two transformations will go concurrently, hand in hand, in the coming decade.
Thank you for that. That's a very, very good, interesting answer. So it's not only just the companies that can use digital to go green, but because of the reach of digital technologies, now going green is available to all the consumers themselves. So thanks for that insight. So my next question, or the similar question to Frederic, can you talk about how Schneider has used digitalization to go green? Specifically, your SF6 free technology, has that, have you benefited from the digital revolution?
Yeah, so the more we work on technologies is making sure first the base of the product is greener and greener. I was explaining before that in electricity, to cut the arc, in the past we were using a gas, and we still use it, by the way, called SF6, right? This gas is very good for electricity, but the global warming power is not good, right? Means obviously it's not supposed to go in the air, but when you have to recycle in a way, you still have some losses. So it's not very good for the environment. So we decided to put our research towards a new technology based on air and vacuum, basically, that will allow to replace the gas. Using this technology, because it is air under pressure, we decided to integrate digital directly into the product to control the pressure and making them more safe. And then when you start to do that, which was our initial line of thought, right, we went into a generation of sensors that are now completely easy to put, like thermal sensors, humidity sensors, partial discharge sensors. So we came with a generation of products. So initial intent was, okay, let's make greener product. And now we came with a generation of products that are green, which is good, but as well with a lot of capability to be remote controlled, remote monitored, offer much more functionalities to the user. Obviously, being able to monitor directly the energy that goes through the product, because one basic thing is that once you have a breaker, the flow of energy goes through it. So you can monitor the flow of energy. And I saw a question on the chat, how users are monitoring their consumption and so on. So of course, residential people may not all be monitoring their energy, let's be very clear, but some large users are monitoring energy, and what they want is basically to know as well the energy of a given department and so on. And we are able now, with new generation of products that are greener, to give as well energy information to the user in a much more detailed way. And we can do it because we've got those source of information on the cloud, so accessible to anyone at any time, which is another big difference, right? Is that before, if you wanted to know what is the amount of power that has passed to go into this department of the company, you had to go in front of the product and look at a meter, right? That's what you were doing, right? Today, you don't do that. You go on your laptop, you connect, and instantly at the end of the day, at the end of the month, you've got your amount of energy. You've got eventually a summary of the problems you had. You've got, you ensure that your product is well under good condition. So you open a world that is completely different, right? And what the pandemic has all make us progress a lot is, for sure, we spend less time traveling, so we have more time to look at holistic data. And I believe that's a big change for the future, is that people will probably, hopefully they will travel a bit more than today. I hope we will be able to re-travel because it's good to meet people. But people have taken this year the habit to access to information without traveling. And that is a big change.
Thank you, Frederic. Yeah, I agree. Missing traveling and meeting people, right? That's a big
that's a big thing, right?
Yeah, yeah. One thing you said, very interesting, implementing digital and trying to solve problems leads you to the development of products like sensors and everything that have significant side benefits. So thanks for that insight. So the next question is to Praveer. I know that Tata Power has done a lot of work in renewable energy and going green. So I'd like to ask you a slightly different question. How is this digital transformation helping the smart grid, is the smart grid helping global warming or going green?
Yeah, the smart grid is definitely going to help in reduction of energy consumption. And as I mentioned to you that today we have a much better line of sight in terms of what is the demand of electricity and how it has to be met. I remember many years back, we used to do the load forecasting and plan the demand based on the peak demand of electricity. And that much was the quantity of power that we used to typically go and tie up on a long-term basis. But nowadays, because of better understanding of the demand and also understanding as to for what period that peak demand is there, we are able to optimize our resources. And just to give you an idea, we did the analysis of the peak requirement of power, and we found that the top 10% peak requirement of power is only used by us for about 100 hours. Now, out of 8,760 hours, 100 hours is just 1%. And that means that we have plants which are not being used for 99% of the time. So for 100 hours, I have a requirement of this much power. Now, the options with me is that for these 100 hours, I tell the consumers that I will not be able to supply you power, the top 10%. And you can imagine in a city like Delhi, when the temperature is 45 degrees centigrade and 47 degrees centigrade, you tell people I will not supply you 100 hours, they will ransack your office. So you can't do that. So what do you do then? What is the alternate that you do? So the two alternates that we looked at, that can we have rooftop solar, because your peaking typically happens in summer months, and can you have rooftop solar which can meet the requirement? But then rooftop solar is good during the daytime. You also have a peak in the night. So what do you do in the night? So can you have some storage which can meet the peaking requirement? So the additional energy that you generate during afternoon, you store it in your battery, and that can meet. And partially, can you also do the demand response? So that means that you incentivize, financially incentivize some consumers that during the night period, certain hours, they can either shut down the non-essential loads or non-critical loads, and start after the peak hour has gone, which typically would be about 2 hours to 3 hours in the afternoon and 2 to 3 hours in the night. So by doing this sort of load management, you are able to unnecessarily stop capital expenditure which one would have incurred in setting up new coal-based generating plants or any of the hydro plants, and also the transmission system. So there is a great opportunity to now manage your load in a much better way. And whether it is your smart grid, smart metering, and the other automations in terms of the automation and the SCADA system that you have, you will be in a much better position to handle your load. And I think we have seen this, and we've done a lot of studies on this. We did proof of concept, and now we are scaling up. And that has helped us to also project that in next 10 years or next 20 years, notwithstanding the growth in load that will take place, do we in future go and tie up any more conventional power, or meet this by adding more of rooftop solar and more of storage and more of demand response? And when we did a simulation up to 2040, we found that in spite of a growth of about 5% in energy consumption every year, and also in peaking power requirement, we would still be able to manage it with the better rooftop solar management and some of the other distributed energy resources, which can be either at the edge of the grid, or it can be behind the meter. And to that extent, I think it's a big step towards greening the grid and also reducing the carbon footprint.
Excellent, thank you. I'm going to steal your answer for some of the questions I get. So, good way, really good way to think about what you just said. So, thank you for that. Using the digital technology basically has enhanced some of the ideas around the smart grid, like you mentioned, demand response and managing DERs and all that, and allowing people to make decisions that they can choose to be green. In the interest of time, what I am going to do is move to audience questions. I do have some specific questions for each of you. After a few audience questions, we can maybe come back to that. The questions I have specific to you are of big interest to Plaksha, so I would like to ask that for you. So I have a list of questions from the audience members, and I will read the question, and then any one of you can feel free to answer. So the first question is, India is getting rapidly urbanized. What will it take to ensure this digital transition is pervasive? And how does the transition help with accessibility, affordability, and availability in rural areas? In other words, how can we spread the benefits of digitalization to everybody? So since it's more of a is this, we can look at this from a policy perspective or a product and technology perspective. So, Mr. Kohli, you want to talk about how policy can help this?
I think the answer lies in a mix of policy and technology. Clearly, rural India, and I worked very, very deeply in rural India. I took the mobile coverage to more than 5 lakh villages of India, and I know what happens because all the towers we built at that time had diesel generators, unfortunately. And why? Because there was no transmission reach up to those villages. Now today, one, the transmission has improved a lot. Second, the big project of government to take electrify villages has really been fantastic in the last 2 years. They are not talking of one house per village, they're talking of all houses, every village, which is fantastic. And yes, Bihar and UP were a bit slower than other states of India, but they have also caught up very well. The third aspect is that now the dependence on large plants, of large thermal plants or large hydel plants far away, 1,000 kilometers, 1,500 kilometers, that dependence has gone away. Plants can be closer to you. They could be solar plants, they could be wind plants, they could be hybrid plants, they could be biofuel plants, they could be all kinds of plants. So the sources of power are multifold now. They're not limited to 1 or 2 sources. And therefore, within maybe a few hundred kilometers, there can be the generation of power. So getting to villages has become easier. One, because of transmission reach. Second, because of plants being decentralized. And of course, rooftop makes it totally decentralized. Third, that affordability, these new sources are making the power much more affordable. So for example, in villages, I don't think they can afford power for 6 rupees or 7 rupees, but they can definitely afford it for 2 rupees or 3 rupees. And that is where we are going. So I feel that both technology and policy are leading to this deep penetration of power into villages of India.
Thank you, Manoj. The next question is how do you validate the efficiencies delivered by clean technologies such as CHP, e-mobility, or smart energy techniques? So I'm going to direct that to Frederic. Basically, the question is, can you measure or can you validate the promises of these new technologies and their impact on society?
Yeah, maybe before I wanted to react on what Manoj was saying on technology.
Sure, absolutely.
Just to explain that we developed in India a very simple solution for remote places in which you can associate a solar panel, a bulb, and a charging USB plug for mobile, right? And this very simple solution, because having access to electricity is the base to access to digital, right? If you don't have electricity, you don't have digital. Okay, that goes along. So, and what I've seen and what Manoj was explaining is very true, is that technology have made now access to electricity much more easy in remote places, much more cheap, because those solutions are basically cost-free. Means if you've got a solar, you need to buy the solution, but if you've got the solar panel on your rooftop, you can already access to base of electricity, which is light and charging a mobile phone. And if you have a mobile phone, then you access to the network, and then you access to the digital world. So basically, today, thanks to technology, we have much more people that can access to electricity and that can access to the digital world. So I believe it's a big change, right? And part of our, I believe, common mission, all of us, should be to ensure that all people access to electricity, which is a base of going into other steps of life. Coming back to your question on what is the proof or how you prove that things are working, right? What we like to do is basically visit our customers after they implemented some of the technology to get a return of experience, right? Most of them have a business case when they implement. So take the example of a distribution utility, right? Of a data center customer, of an hospital. When they implement technologies, they have a business case, basically. They say, okay, if I automatize, that's what I would like to reach, right? The business case can be very different. For some of them is CO2 savings. For some of them, it is more efficiency. For some of them is a question of image, because to be more seen as a green company and so on, it can be very different. But we always measure after 1 year where they stand compared to their initial goal, right? And we ask them datas. And for some of them, we even ask them to publish the datas. Do you agree that we co-publish the datas on what has happened? So we look at the way technologies are bringing returns, okay? Today, in terms of measuring the returns, I see two big areas, right? CO2 savings, and here we have clear data points on how technologies have allowed to save CO2 emissions by using less energy, basically, or efficiency, which is another big source of efficiency. Can be, okay, if I had to do that in a traditional way, that's what it would have cost me in terms of travels, in terms of power, in terms of whatever, and how we compare that with the way we do it with digital technology. On all those examples, so CO2 emission and efficiency, we have data points that range easily on the savings that goes around the 20 to 30% when technologies are well used, okay? So when you use well technology, you can save 20 to 30% on your CO2 emission. You can gain 20 to 30% on efficiency on the domain you're targeting, which makes huge savings. Okay, and it's true for residential users as well. If you take a bit of control of your energy usage, you can make big savings.
Well, thank you. Yeah, so the answer essentially is it depends, right? So you have to look at what the end user is looking for.
Yeah.
And once you know whether they're interested in the green side of things or on the money side of things, you can definitely measure the impact of these technologies and put numbers to them. So thanks for that. The next question I'm going to direct to Praveer. In fact, this is of big interest to Plaksha too. What are the opportunities in the digital transformation of energy for a budding entrepreneur, right? We want to create job makers instead of job seekers. So can you shed some light on that? How can all of these benefits help young startups?
There are huge opportunities for startups, and I always feel that I miss the opportunity of many of these things, which only in last 10 years I see changes happening. Starting from coming up with an analytical tool for demand forecasting, and I can tell you that the quality of demand forecasting in India is very, very poor. Barely any state utility uses that, and the data sets which are available is not very good. In fact, the weather data, which is the prime requisite for doing load forecasting, is very poor. Though the IMD data has improved in last few years, but it still is very, very unpredictable. And to that extent, how do you then develop an algorithm for that? The second area that I feel is a lot of analytics can be done in ensuring reliability of equipments, whether it is in distribution business that you have or in transmission, whereby again using the data you can do a forecasting in terms of maintenance and condition-based monitoring and what sort of maintenance and replacement repair. This is also true in renewable projects using today drones. You can take photographs of the panels and then use that analytics to find which are the hotspots and what strings are operating or not operating. And again, you can do all these analytics by ensuring that, again, what sort of maintenance activities have to be carried out or cleaning activities so that you get a better PLF of the plants or CUF of the plants. Similarly, today the grid is becoming very, very complex and complicated. Unlike earlier times when it was a unidirectional flow of energy, now it is multi-directional flow of energy. Now, how do you do the load management on a dynamic basis? You have all of a sudden 20 cars coming who wants to get charged in one area, and then you have some 50 buses who will go and want to get charged in a bus depot, and then some other spaces where you will have some of these cab companies who are running their clusters over there. So how do you manage your grid on a dynamic basis? How does the load flow take place? And how you are able to move the load from one feeder to another feeder and ensure that otherwise at every location, whenever the peaking takes place, you will put additional capacity, which again will be very, very underutilized. So I think today there are a whole lot of areas that work is going on. You mentioned about rural electrification. Can you use satellite imagery to decide what sort of rural electrification should take place? What should be the capacity of the microgrid in terms of the solar panels or storage or whatever backup is there? How many villages or how many people stay in that village? What is the optimized design in terms of feeding not only to the households over there, but also to the commercial activity and industrial activity that would happen over there? So I think I can give you a long, long list of things that can be done. And I also work with many of the startups, and we do incubate many of the startups with us in Tata Power in Delhi. We also do some of them over here. We have also tied up with some of the institutions abroad who are doing many of these research areas on digital technology and how energy access and especially universal access of energy can happen in a much better way. So I think it's a very exciting area. This is one of the areas where maximum amount of research activity is going on. I mentioned about the technology. There's a lot of behavioral changes which is happening and socio-economic changes that is happening, and how access to energy is bringing the socio-economic changes and behavioral economics in the local communities. So I think if you look at energy, everything revolves around that. If you have no energy, you have no mobile phones, you have no entertainment, you have no TVs, you have nothing that can happen in any. And the way the energy access is improving now, and with the way digital technology is penetrating in these areas, I think young students in the Plaksha Center for Energy has a whole lot of work. The question is how much they can do and how much they can deliver.
Well, so I hope the participants were taking notes. There were a lot of opportunities identified, essentially using digital technology to solve these problems. So there are plenty of opportunities for entrepreneurs. If you didn't take notes, I encourage you to go review the videos. I think they'll be posted on YouTube later. So before I move on to the next question, this is kind of related to the previous question. So I'd like to reach out to Frederick again. Specifically, right, with respect to Schneider and otherwise, what do you think are the opportunities in India for research and development and for technology transfer, anything that can help young entrepreneurs?
Look, as a global company, we want not to be global, we want to be multi-local. And we built our R&D in places that basically will drive the future of energy. We see basically 4 places, and India is one of the 4. Okay, so means in India, we want to have local capability in R&D. We want to have people who listen to the market and understand where the market is going to. And we want to be able to associate our R&D with local entrepreneurs so that we get more dynamic for local solutions. There is a common problem in the world, which is to decarbonize. Okay, that's a common problem. Now, the solutions may be very different in large countries. And when I say 4, it's pretty simple. You've got India, you've got China, you've got Europe, and you've got US. And that are the 4 places that may go with different answers to the same problem, which is to be greener and decarbonize. I don't believe that an answer in Germany can be applied exactly in the same way in India. I don't believe so. So we need to have local team that look at the problem, that use global bricks, but that adapt those bricks to a local problem. So basically the way we look at India, where there is a set of energy problems that are very specific to the country, where there is as well some infrastructure challenge sometimes, I believe the solutions will need to be specific in India. I was mentioning before this village or this home in village solutions we did with solar and the USB plugs. This has been developed in India for India first. Now it's a big success in Africa, and we use that in Africa as well. But it has been developed in India to answer an Indian problem. And that's what we want to have. So having teams that are connected so that they access to global bricks, but having local development and associating local entrepreneurs in the countries because they see problems that are specific to the countries and that needs to be fixed. The advantage in India is that the scale of the country, the size of the country, make it affordable to develop solutions just for this country.
Well, thank you. Thank you for that insight. The next question I'm going to direct to Mr. Manoj Kohli, and I'm going to reword it slightly. So the original question is, should the energy distribution sector work in collaboration with the alternative energy sector? But it's more of an economic question, right? So how will it, if economically beneficial? So One thing I want to ask is, are there any financial barriers to this digital transformation, the promise of digital transformation to reach everybody, right? Like you were talking about. And are there any new financial instruments that have come up to help reduce these barriers?
Thank you, Srinivasan. You know, the distribution in India is a very complex topic because it's controlled by the state governments, except for Tata Power, Reliance, and some other companies who led the privatization in few metro cities, or in Calcutta, CESC, etc. Now, I feel that this is the weakest point of Indian industry. And if this we can sort out and resolve, I think Indian power industry, electricity industry will be very healthy. But it's not easy because we are talking of billions and billions of dollars of accumulated losses. It's not an easy thing to do. But we can definitely find a solution for future. And I'm going to recommend two solutions. Number one, that renewable energy cost will continue to go down in the coming years. It's already 2 rupees at generation point. And if you add some overheads of distribution, it can't be as much as what the retail price is today. It will be much lower. And this 2 rupees trend will keep on declining. But because this is intermittent, it has to be blended with thermal or other baseload sources. But in the blend, renewable energy may start at a smaller percentage, less than 50%. But gradually over the next 5-7 years, it will grow as a percentage. And finally, I think when the storage becomes as affordable as solar, which will happen in anywhere between 3 to 4 years or 5 years from now, then renewable energy will be a substantial portion of this blended energy. Now, this will help in distribution because it is very, very affordable. Not only for retail consumers, but also for industry. Today, Indian industry, let's say Indian manufacturing, is not as cost effective as China or some other countries like Vietnam, Malaysia. It's only because one is the power cost is high in India, whereas we subsidize consumers and we load the industry, which is fundamentally illogical. We can't be loading industry. Therefore, industry deserves affordable pricing so that it can compete with China, Vietnam, Malaysia, and other important countries of Southeast Asia. Now, so I feel that this change of renewable energy blending will support deeper distribution to both consumers and to industries. The second idea I want to share is a digital idea, which I have employed across the country in my earlier industry. I'm sorry, I'm giving a telecom example again. Telecom is 99% prepaid in India. Not 99, 99.5, with zero bad debt. Zero. And that 0.5% which is postpaid has 2 to 3% bad debt. Clearly, India needs a prepaid solution. And you don't have to train Indians because Indians are already using telecom for last 20 years on prepaid basis. So I've already recommended to Government of India that along with smart meters, and smart meters and prepaid can go hand in hand because both are digital. And I believe that if India gets all the smart meters in the next 3 years, prepaid will be a very fast transition. Because we did this in telecom in 98, 99. And we did this so effectively. Today, nobody is complaining. Even in villages, people who don't understand the prepaid electronic mechanism, they don't complain. So in one stroke, you take away, by transition to smart meters and prepaid system, you take away issues of billing, issues of collection, and issues of customer care. So it's very important that we use digital technology for uplifting our distribution from where it is today. But all these solutions I'm suggesting are future solutions. But the problem of the past, accumulated losses, etc., that solution has to be found by government. And it's not going to be easy because it's a very large problem to be resolved. But I understand government is really thinking seriously about it. And if they're able to resolve it soon, I can tell you then Indian power industry will transform much faster. Thank you.
Well, that's excellent insight. So basically, use digitalization and examples from successful implementation in another industry to reduce the fiscal barriers to digitalization in energy. So yes, thank you very much. So we're coming to the close. I have one last question, and I will direct it to Frederic. And then actually after that, I do, if you don't mind, just take a few extra minutes to ask a generic question to everybody regarding Plaksha. So question, Frederic, is what is the role of digital when planning energy demand?
It's an interesting question. We didn't look at it that much in the past, right? 5 years ago, I would not even have answered your question, most probably. We started to look at it when we understand there was a big constraint on choosing the level of investment and making trade-offs between various investments. So we invested research, and we basically are about to conclude an acquisition in this domain, because we consider that planning, the demand side, having much more scenario planning is extremely important, and here digital can play a large role. So if we combine a good distribution management system, which is the OT platform of a utility, with a very solid planning system, first, we can generate very big savings in terms of CapEx, right? And second, we can help the CEO or COO to plan scenarios, right? What this year has learned us is that it's very difficult to predict the future. We would have had the same meeting 1 year ago. I believe what all we would have said would have been bullshit, right? Frankly, the year has been the same meeting in January last year would have been completely different tone. So we need to be extremely humble on our capacity to predict. We need to be much faster at running scenarios, and the scenarios can bring much more disruption. The advantage of digital in planning is that you can run scenarios, make trade-offs between your investment, and put the money in things where you would not have imagined to put the money on. So we are about to conclude the buy of a company called ETAP that is very strong in planning, and we think that having ETAP and our strengths in distribution management system can offer to distribution utility a good way to predict the future. Okay, now it is clear, and to come back in what Manoj and Pravir said, is you need to have obviously a base of business that is healthy. That's obviously important if you want to keep your capacity to invest. But looking at that is very important. Looking at planning is very important. That's a new area where digital can help to change gear.
Well, thank you for that. That actually also answered one question that I wasn't able to ask because of time, and that is, essentially asked what you can do to predict when the benefits of this digital transformation will go to everybody. So sorry, it's my phone telling me that it's time, but I'm going to take a few more minutes. Just to summarize, paraphrase what you said, it's difficult to predict the future, but you can use digital technologies and planning tools to make some predictions and reduce the risk of these predictions going the wrong way. So thanks for that. Thank you all. I know that the time is just too short for something like this. I haven't even got to 10% of the questions that I wrote down. So, very, very important topic, very relevant and timely. So before we end, I would ask each one of you to think about Plaksha, its students, and the question to each one of you would be, what would you say is a call to action to the participants and to the students and faculty at Plaksha? What would you like, what is the call to action? So can I start with Manoj again?
I think energy transformation of next 2 decades is the biggest theme for students to take up. And call for action is how to mitigate the side effects of this transformation. In my view, there are 3 side effects. One is the side effect of that fossil continues much longer than we want it to continue. And there are lobbies, there are groups which we want it to continue. So we have to try our best to inject renewable energy faster than expected. Number 2 issue is the skilling issue of manpower. A huge issue. All the coal miners, all the workers working in thermal plants, etc., have to be reskilled, upskilled, because I think those are jobs which may not be available in future. So there'll be more jobs on the renewable energy side. The jobs in the oil, coal, and such fossil power will gradually, systematically, will have to be upskilled or reskilled. So that's a very, very big national mission which we have to take, or international mission which we have to take. And the third major issue is that if we expedite the transition artificially, before the PPAs of the thermal plants end, or before the debt which was taken to build thermal plants is fully repaid, the banks will suffer NPAs. And that is not our objective. Our objective is not to make banks weak and banks have higher NPAs. So we have to do a very coordinated or collaborated action plan between government, private industry, banks, so that the entire debt taken for various fossil plants is fully repaid before the transition takes place. So the point is that the side effects of a transition, all this big transition, have to be mitigated in a very organized, systematic, orderly way, in a joint venture by government, industry, maybe industry associations like CII, and of course, some experts from your institution, Plaksha, who can help in this process. Thank you.
Thank you, Manoj. Can I request Praveer to go next? What is the one or two call to action that you would issue to our students, faculty, and the participants at large?
I think there is a huge disruption that is happening in the power sector. And what was good yesterday is no more good today. And this disruption will get accelerated. While the challenge of renewable energy is that it is intermittent, but with the better load management, one will be in a position to come up with hybrid solutions, which will be able to meet both the peaking requirement as well as 24/7 power. The storage prices are coming down, and with more research that will happen, not only in the traditional lithium-ion batteries or the lead acid, but other chemistries. So I think there is an opportunity to do more research in what are the new chemistries in which the batteries can come. Not only batteries, other storages, which can be mechanical storage or thermal storage that can come. That's an area. Hydrogen will play a very, very big role. I think later part of this decade, we will see huge amount of hydrogen making penetration in various areas, not only in the energy area, but also in transportation and some of the other large industries. So I think it's a question of how much of research we can do and how much of cross-functional work that can be done. Today, understanding IT, understanding communication technology, understanding data analytics is a prerequisite for an electrical engineer. It's not a choice that I will only do electrical engineering and not. In fact, I can tell you that last 3 years I've studied more about communication technology than I have done for electrical technology, because real-time communication is a challenge, and whether the GPRS system is good enough or we need to have the RF and the other technologies for communication. So I think there is a whole lot of convergence that is taking place, and with more and more data that is coming in, there is a ability to do much better prediction, notwithstanding what happened in COVID. But I do hope we don't have every year similar COVID scenarios, and we should be back to normal. So I definitely feel that Plaksha Center has a great opportunity. They need to work very closely with the industry to understand what are the changes which is happening. There is a huge shortage of people who understand these technologies. Indian power system has been using old technologies, and everyone, in fact, keeps on telling me that what will happen to the Indian power system with cyber security. Nothing will happen, because none of the grids in India are system driven. They are all manual driven. So there is no necessity to worry, at least for the present, for cyber security in the Indian condition. So I think there is a huge demand of retraining and people understanding the new technologies. Unfortunately, in India, in last many years, people have not gone to the power sector. There have been much better areas that people have gone, and especially in the knowledge industry and IT industry. I think more people have to go into power sector and find that there is a lot of technology and a lot of learning that can happen over here also, apart from just working in the IT area. So I would urge the students and the faculty to get more involved. I do find that in India, there is very little of research work that happens in smart grid and smart technology and power sector technology. Most of the work is happening outside India. So there is a great space and opportunity, and it is left to the students and the faculty as to how they gear themselves up and train themselves for taking this opportunity.
Thank you. Very good. So, Frederick, you get the last word. What do you think? What would you like us to do?
Look, my call for action will be on decarbonization, right? It's I think that is that is a big challenge we all have, is trying to build a world that is more sustainable, a world in which we still use and consume energy, but in a better way. And as I was explaining, there probably was a time where people would say, okay, finally, what can I do? I work in the demand side and I can do nothing. Today, as I explained, everybody, wherever you are working on the energy, everybody can do something. If you are in a generation company, you can work for a greener world. If you are in distribution utilities, of course, you can help for a greener world. If you work on the demand side, on the energy problem, you can help as well to work for a greener world by saving energies and by using new technologies. We need more people because it's probably, and it has been said by all my colleagues, it's very exciting transformation. We need more skilled people, people who understand digital and who wants to build a better world for tomorrow. We need those skilled people into generation, into distribution, and into the demand side, so that they all help to transform the world into a greener world and a greener tomorrow. You know, when we went through the pandemic, it was interesting to see in April or May, in many countries, people saying, oh, the good side of it is that the sky is blue, the noise is, okay, that was what people said. Now they all say, oh, it's enough, we would like to travel and meet people again, right? I hope that we will be able to travel, meet people again, but in a greener world. And that's where we need talented people. That's where we need more people joining our company. With decentralization, everybody can play his role. Everybody at all levels.
Thank you very much for that. I wish to express my heartfelt thanks to all the panelists. Lot of very wise advice. We will definitely take all these to heart. We have been taking notes and recording the video. So thank you again, Manoj, Praveer, and Frederick. It was a pleasure. And now I'm going to turn it back to Piyush. Thank you.
That surely was an insightful session. Thanks to all our panelists and the moderator for making this session interesting and for the inspiring call to action messages. We have come to the end of this conference. I would like to invite Anurag Mishra, Program Manager at the Plaksha Center for Clean Energy, to deliver a vote of thanks and conclude this conference. Over to you, Anurag.
Thank you, Piyush. So we have come to the close of the event, and it's been a very exciting 3 hours with 3 very varied sessions. So on behalf of the center, I thank all the speakers and participants for joining our inaugural conference. There is a very incredible team who has put this event together, and there are so many names. Nani, Samriddhi, Modit, Sachin, Piyush, and the whole communications team. And our founders have been a continuous guiding light in this process. So we are thankful to everyone for their help and support. Plaksha Center for Clean Energy is in endeavor to make the world and planet a better place by supporting clean energy transition. We hope that we will be able to emerge as a torchbearer in the next few years. We'll soon share a feedback form, and you can also write to us with your comments and suggestions on the details that you can see on the screen. We look forward to seeing you soon in our next events. Wishing you a great time and year ahead. Thank you.